Perfect. So good morning, everybody who is online and here. We'll wait for 5 minutes, maybe, for a few more people to arrive, and then we start. Yeah, we can slowly start. Yeah, if it's okay. Cool. Yeah. Okay, we can start. So I guess we can slowly start. I don't know whether the online participants see us, whether they can follow and hear us. Can you make some sign that you are there? I'm looking at the screen with the participants. Yes, I can see some reaction. That's excellent. So thank you. So we are all ready. Welcome back on the second day. Yesterday was a relatively long day. A lot of information came your way from both Priyankoo and myself. We have a lot of questions and some vague ideas how to address them, and we will start sort of proceeding, hopefully, towards sort of figuring out and learning and getting used to the ways how we actually analyze some of the language diversity and variation from typological point of view using machine learning methods. Today we will dedicate mostly to databases, because of course in order to do this type of data-driven analysis or data-driven visualization of some sort of relationships between different linguistic units, dialects, languages, prosodic patterns, whatever we decide to analyze, we of course need good data. So we will talk a little bit today about the data, and hopefully we are very excited about the prospect that maybe by tonight we will have not one but two databases, which we source from you. That we are going to dedicate this afternoon session, the tutorial, to really do hands-on job and prepare the database, which we will then be able to analyze tomorrow and day after tomorrow. And maybe by the end of the week we will even get some new results. We'll see how it goes. As I said, we are very excited. It's going to be, it will require a lot of concentration. I would like to ask the online participants as well to join in the tutorial if they can, and sort of and also process the data. We will all do it. I will be guiding you. We'll show you what we want, and hopefully we will kind of reach some consensus and prepare some database. So I'm going to be talking about the databases a little bit from the sort of overview thing a little bit later today. But first thing, I will run you through some sort of examples and reviews of some machine learning based analysis. Priyankoo has shown you yesterday some results of some sort of way of more standard phonetic analysis of tonal patterns and many other prosodic phenomena, also partly sort of machine learning driven, using all classifiers and sort of statistical modeling and things like that. And instead, I will today show you some results. We are not going to go to any details. Some sort of results, highlights of the phonetic prosodic typological analysis driven by the deep learning methods.
Hello, sir.
When I was a PhD student, my supervisor started writing my first conference papers and journal papers in particular, and my thesis itself. My supervisor, Dr. Fred Cummins, yes?
You're right. Now the video is there, but we could not see the video until now.
Okay.
Just now video has came back. Okay, thanks.
That's absolutely fine. So I'll just start the previous sentence again. So when I was a PhD student and started, my first attempt to write conference papers, journal papers, and then of course starting putting my PhD thesis together, my PhD supervisor, Fred Cummins from Dublin, told me that when you write a scientific text, we are not writing a detective story. We don't need to keep the the reader in suspense. You don't have to kind of, put all of the ingredients in and then at the end as a surprise, or maybe less of a surprise, come with a sort of secret message. It's good to reiterate things, it's good to repeat, and we can sort of spill the beans, we can tell who is the murderer at the very beginning, ideally in the abstract, so that the reader knows what's coming, and she or he can, like go, oh wow, this is how it might go, this is what it is for. So I'm going to do something a little bit similar, and I'm going to show you the results of our analysis today. I spill the beans. What can we do without really going into details? Yesterday we did some small introduction to the machine learning things. It might have been straightforward for some, maybe slightly more challenging for the others. But we are doing this, we are trying to do this sort of in this iterative way. So now I'll show you what can be done, so we can start thinking what type of analysis we can do. And these are only a few examples. I'm going to show you 3 or 4 examples. And then tomorrow, day after tomorrow, we will actually try to show you how it's done. So we know some basic ingredients. You will see the end. We'll know who the murderer is. And next, we will hopefully try to find the path, how we actually found the culprit. So, as I said today, I will sort of talk first about 1 slide, 2 slides, about sort of the basic ingredients into, when we want to analyze speech using machine learning things. And I'll show you several examples, essentially. That's pretty much all. So what are the basic ingredients? So number 1 ingredient is the question. We want to have some question. We want to know some answer to some, ideally, phonetic, prosodic, linguistic question. How are different dialects distributed around some particular area? What are potentially relationships in some particular phonetic, prosodic aspect in between some languages spoken in the world? How are regionally varied realization of some particular pattern or something like that? Not every question can be addressed, as to my knowledge, with my level of imagination, not every question can be addressed by these type of methods. There are some questions which are better, some which are maybe more difficult. So, of course, all of you are doing some particular work, all of you are driven by some questions, whether they are sort of practical questions, somebody told you to focus on that, or you have a burning passion to kind of find the answer to some particular scientific sort of mysteries, to solve some scientific mysteries. So, of course, you have to then figure out the methodology, which is the right type of methodology for the given question. And of course, this methodology is not the right methodology for every possible question you might have. But maybe for some, it might work fine. Second, of course, we need a suitable data in order to address this question. So we need to have the data, which I'm going to use the term source of variation. I'm going to repeat it today a few times and throughout the course. So we need the data which contain which can serve as a source of variation of the phenomenon we want to investigate. This doesn't necessarily, there's nothing mysterious about that. When we want to investigate dialects, we have to have a database which is varied enough in an appropriate way in terms of dialectal speech. If we want to investigate tones, we need a database which is varied in terms of tonal realization. We want to investigate some gender-based differences between some realization of some particular speech patterns or phonetic patterns. Then we need a database which contains reasonable representation of all the genders you might be interested in, that type of a thing. If you want to look at the age, how the age potentially determines some speech of the participants. Maybe you are kind of thinking about kind of how the sound change. There might be some ongoing sound change or influence from some other dialect or some creolization, and you kind of think that older people sound different to the young people. Then again, source of variation is the age of the speaker. So you have to have the database which contains the reasonable variance along that particular dimension. And of course, then we need a technique, some particular methodology. We need some appropriate combination of sort of signal processing, in this particular case, machine learning and visualization techniques. It could be, of course, machine learning might not be appropriate method, so you might kind of use some statistical analysis, you might use whatever, you know, random effect models or some more straightforward analysis or anything. Quantitative analysis, qualitative analysis, all of those things are possible. All of these three ingredients are interconnected, of course. You know, as I was saying, you know, the question you have to have, for the given question, you have to have the right type of database. You know, for the right type for the database, you need the right type of technique. For the given technique, you might need right type of database. For example, sadly, for the machine learning exercises, we sort of need big databases. You know, we need a lot of data. If you want to look at some very narrow, small, interesting phenomenon, you might want to design some standard phonetic database where you kind of create the variation along the very small dimension and in a very precise way. So you have sort of a relatively large number of samples which vary along some particular phonetic, phonological, prosodic dimension. And all of those things, I can kind of continue with all of these combinations, how the implications go, you know. So, I'm gonna now, this was all the theory essentially we had for this. So I'm gonna go now through several examples. So the first example is a data-driven typological clustering of world languages based purely on how they sound. This is something which Tukka has actually mostly done. That's one of the questions he was addressing in the last year or so. And so the question essentially is what kind of relationships among the languages in the world can be sort of unearthed from speech signal only. You know? If we are sometimes kind of, when we think about that, and I don't remember whether we have submitted a paper recently, whether we put it there, but one of the kind of ideas, images, metaphors we have for this is that imagine some sort of extraterrestrial landing on Earth. Knows nothing about linguistics, doesn't know how the earthly languages might work, structure, but hears different people making different sounds. And can that sort of completely uninformed, linguistically totally naive person, how would they cluster languages of the world? What patterns would they find? So for the database, of course, we want the world languages, so we need a database containing a lot of samples from a lot of languages. We have used this common Mozilla Common Voice database, which contains, it's a big database collected from sort of many, many languages around the world. I think there are like way more than 100, so not a huge amount, as a matter of fact. Way more than 100. For some languages there is very little material, so for some languages there is more. But and they connect, actually I said up to 1,000 samples because we sort of cropped it, but some languages contain many more than 1,000 samples. And yeah. Of course this database, as always, is not very representative when you look at the world. You know, it's very Europe-centric, of course. The European languages are way overrepresented, like way overrepresented. Almost, I don't know, up to 2/3 of the languages which are contained there are European languages. Indo-European languages are overrepresented. It's part of that. But of course, the Indian languages, at least the major ones, are well represented in the database. African languages are almost completely missing. South American languages are almost completely missing, native languages, but the Southeast Asia languages are sort of represented somewhat, to a lesser degree. Even Central Asian languages are represented, so it sort of depends. It's a little bit of hit and miss. It's an ongoing project, the new and new samples are being added. It's of course Mozilla, it's a corporate owned database, but I think it's some sort of, you know, collaborative issue, so you know they gather whatever they can get their hands on. So the database is growing, and potentially, hopefully, not only in terms of the number of samples of English, but also hopefully in terms of number of languages and minority languages and all that. There is, as far as I remember, Tukka will know better, but there is essentially no Australian Aboriginal language represented in the database whatsoever. So there are these huge gaping holes in the thing. And the technique which we use to analyze this particular data is the combination of wave-to-vec representations and LID technology and linear discriminant analysis. The stuff I was talking about yesterday, not in very depth. We will go a little bit further to the depth in these things, but they are sort of what we were talking about yesterday. We take the recording, we run it through this particular type of representation transformation, wave-to-vec with kind of this context-dependent representation we create, then fine-tune it for language identification, and then we kind of look at what comes out. This is particular methodology which we will go hopefully to some sort of depth, and you will be able to hopefully on Thursday even, we are planning to analyze the database which we collect today using this technique. So keep fingers crossed. So now this is the result. I'm not gonna go through the process. Just, I don't know if you can see it actually very well. But this is a this is a sort of dendrogram, this sort of circular dendrogram, plotted, these, they are the leaves, are the languages here, and when the leaves are together or on the same branch, they are more related. When they are further, they are sort of less related based on this technique, right? This is purely, this tree here is completely data-driven. There's zero linguistic knowledge put into that. It's purely based on the sound. The machine learning technique is completely agnostic to things like language family and the structures of the languages and morphological characteristics and what have you. It only has what it got from this type of machine learning processing. So I don't know whether you can see it very well, but the languages actually are lumped together, are organized in a kind of meaningful way, primarily based on geography, funny enough. So can anybody see those names here? Okay, from distance? No. Tukka doesn't need to see them. He actually created this picture. This is from our recently submitted paper with the Tukka, who is there, and Antti Suni, who is our very close collaborator. And in many ways, his contribution to all of this work is absolutely crucial. Every now and then I kind of try to think that which of the ideas which I'm talking about do not originally come from Antti. He's a very creative guy. So importantly, you can see that the languages are on this sort of circle, organized in sort of geographically. So here comes sort of Northern European languages. Here comes Central, Eastern, and South European languages, mostly Slavic actually. Here comes North African, West Asian, and Central Asian languages, somehow lumped together all the way from the sort of Persian and Arabic here, and even Mongolian and Georgian are somehow linked to that. So, funnily enough, these geographical links, even wider. Of course, Arabic spreads vast amount of the world, from Morocco all the way to Iraq, essentially. So it's a very big area. So that's sort of, Arabic is both sort of African and Central Asian language in some sense. So, but you can see that these geographical links dominate this organization. Here is maybe the interesting corner for you. This is South Asian languages, primarily Indian languages, and the other sort of maybe some other Indo-Aryan and Dravidian languages spoken outside India. Here are the East and Southeast Asian languages, sort of Chinese, Vietnamese, those languages here. And here are several very small, unfortunately, database. That's one thing which we are really feeling sad. These are sub-Saharan African languages. There is only a handful of them, but they got lumped together anyway, And this is a Mediterranean Europe. So these are mostly Romance languages. The leaves, actually, this is certainly you cannot see that because I can barely see that. We will share the slides with you. Priyankoo is working on sort of some way of sharing. These presentations are humongous because we have all of the sounds and pictures involved, so they are like tens of megs. So we want to kind of a little bit make them smaller, maybe turn them to the PDFs. But then we will be able to see all of these things in more detail. So these leaves here, as you can see, are colored by sort of language family and subfamily. Of course, if we colored it by kind of large language families, whatever 2/3 of those languages would be Indo-European, so that would be kind of boring. So for Indo-European languages, which as I said, like vastly overrepresented in this database, we get these subfamilies of the Indo-European languages. So these red ones here, the dark red ones, are actually Germanic languages. These lighter kind of orangey ones here are Slavic languages. These sort of peach color languages are sort of Romance languages, and here these lighter peach color languages are Indo-Aryan languages, and well, yeah, that's why I think that comes from Indo-European. And of course, you can see that these Indo-European languages are sort of joined with the other non-Indo-European languages spoken in the area. So for the Indian sort of branch here, or this branch here, is sort of the South Asian Indian part. So you can see that, for example, Telugu, Tamil, Malayalam are here, along with the other languages spoken in the area. You can see, for example, that it actually works quite neatly, because here this branch is actually sort of Eastern. Eastern Indian, there is this one. There is a Assamese next to Oriya language, Bengali, Nepali, and Santali, where Santali spoken in. Sorry? Okay, but somewhere nearby. And here is a sort of the Diveli and Telugu, Tamil, Malayalam, the sort of South Indian languages, and Urdu, Hindi. Unsurprisingly, there are recordings labeled as Urdu and Hindi. Unsurprisingly, they are by miles the nearest language in our database, by miles. We can, of course, have different visualization when we can see distances for different pairs, but they are much, well, there are no other two languages in the database are anywhere near that close. That doesn't surprise you, I guess. The one other thing is that what I want to show again, and then I mean to go forward. I don't know what time is it actually, but it's fine. So these are sort of Northern and Central and Eastern European languages, and these green things here are Uralic languages. Uralic languages, it's a smallish sort of subfamily of languages with there are sort of several Uralic languages spoken in Europe. A branch of them is Finno-Ugric languages, so Finnish, Hungarian, and Estonian are Finno-Ugric languages, and the other Finno-Ugric and other Uralic languages are spoken in Russia. I think it's one of the just about European side of the Ural Mountains. That's deemed to be sort of the original area where these languages sort of evolved, and then some of the peoples from that area migrated to Europe, and they split at some point. Some went north to the cold part of Europe, and they ended up being Finns and Estonians, and some went south and ended up being Hungarians. Of course, they had a very long and lively journey on that. I think that some ideas is that this sort of original split started, I'm not a linguist, but I have heard somewhere that started like 5,000 years ago. So that's been a long journey. Nevertheless, and even the split between Hungarians, which went south in Europe, and the Finns and Estonians, which went north in Europe, also happened a long time ago. That happened 3,000-4,000 years ago, if I understand it right. Nevertheless, in Europe, these three Uralic languages clustered together. Of course, Finnish and Estonian are still closely, almost mutually understandable languages. They are still relatively closely related. Hungarian is not mutually understandable at all. It's like lexically, it's almost completely different. Structurally, it's still quite similar. Morphologically, it's somewhat similar, but otherwise, they are sort of like they really needed some effort from the linguists to actually realize that they are related. I think that was actually one of those efforts by von Humboldt, which was almost the foundation of the entire field of topology. When the German scientists noticed that there are some strange people in Europe who sort of speak differently from the others, not like differently like the Germans and French would speak, but so that actually Indians speak more similar to us than these strangers. And there was Hungarians and Finns, and they were like, but actually, bizarrely enough, they're somewhat similar. So then when this sort of typology started, essentially. But they sort of structurally, linguistically, close related kind of third cousins, like these are Eastern Western Mari, Moksha, Ezria, other languages, who are spoken in Russia. They are clustered with Russian and all the other East Slavic languages. Now, these are all, many of these, of course, people who are the minority language speakers in Russia are, of course, multilingual, at least bilingual. And maybe their means of daily communication might be Russian. So one can say that they have Russian accent in the Mari, or the other way we can say that the Mari has been vastly influenced, prosodically, at least phonotactically, phonetically, by the majority language. And this probably is the case in many other places. For example, Irish Irish and Welsh are actually clustered with English. Because again, the same situation. Most of those Irish and Welsh speakers would be bilingual in English, and they would simply, on average, sound a little bit like English even when they speak quite unrelated language. Mm-hmm. Cool. So this is a type of a tree we can achieve, and you can see that, you know, it's kind of mesmerizing to watch. We spent like a year writing the paper, mostly because we were just going and checking all of these things and kind of could not believing and rerunning things because we couldn't believe that it works so well. So example 2, effects of age and gender on dialectal variation in a large corpus of spontaneous Finnish speech. So the question here is kind of straightforward. This is another Ostuka's work actually. Question is, do younger people speak less dialect, the speech of Finnish young people somehow less dialectal than of the older people? And is there some gender difference in this type of, in type of relation of dialects? So we use this so-called donate speech database of Finnish, which is a huge database. It's a kind of public project. It was started, and I think now maybe we will run the second round by our colleagues in Kielipankki, which is the language bank of Finland. That's the organization in charge of sort of maintaining the databases of Finnish textual and speech-based databases, and the state broadcaster in Finland, Yle. So the state broadcaster ran this campaign saying donate speech, and then the University of Helsinki created this interface where people can simply call in, essentially. And there were some prompts saying, you know, tell us something about nature or tell us something about yourself. And they filled some metadata, and a lot of people responded. It was a big campaign. There were posters around the country and all that. Something maybe to think about in the area, or imagine all Indian database like that. That would be crazy, you know. So we ended up with a lot of recordings. As I said, it's like 1,900 hours of speech, and I think this is a processed speech, if I understand right. So this is a transcribed thing. There's almost as much, again, yet, which has to be transcribed still, you know. Somebody actually was manually transcribed. People listened to that and retyped it. It's a big project. Of course, the quality of the material varies. People called in. So some people had iPhones, some people called from the car, and some people have kids crying around and whatever, you know. So it's varied. The metadata are completely voluntary, so we have to just trust them. Then on average, they are fine. Some people didn't want to publish all information about themselves, so there are gaps in metadata. You can imagine that this is a tough database to work. But it's so huge that we hope that, you know, the size of the database will somehow compensate for its shortcomings. And again, we use essentially the same technique for this analysis as before. And there is plenty of different results. You can very easily discern the Finnish dialect, for example, from the data. If you just lump all people from different areas together, There are the dialectal map, the dialectal dendrogram we can generate from that copies extremely well the sort of linguistic analyses and actually geography again, geography of Finland and all that. It's again sort of uncanny how precisely you can reproduce the painstakingly gathered linguistic sort of, you know, relationships between different dialects. But this was actually something different. We looked at the way how potentially these sort of dialects are realized by female and male speakers in the database, and how they are realized by sort of younger people, middle-aged people, and older-aged people. So we split the data because there is so much. We could split them to all of these categories and have a look. So this is not easy graph to read, but doesn't really hugely matter. Again, you will be able to look at it in detail, and you can have a look at the paper. This is very accessible paper, in my opinion. You can have a look at that. Many other sort of pictures and results presented there. But basically, what we can see here that these are sort of the dots for different speakers, as it were, representation of different speakers, and these ellipsoids around there are kind of dialects, as it were. So this is one dialect, other dialect, etc. They are the same. I don't remember 17 dialectal groups, which are or regional groups, which are realized in Finland. All the things, these are rather subtle, but essentially, if you look at the picture here, these are the older males. Each of these dialectal areas is much smaller compared to younger females. So you can see that the older males from the given area all sort of speak more or less alike, or more alike than the females from the same area, the younger females. So the dialects are sort of in this particular visualization sort of more dispersed. They are more different from each other, as it were. So the older people from the south of Finland sound more or less all the same. All the male in particular from northern Finland sound more or less the same, and they sound quite different from each other. While there is a bigger variation among the younger female from the south and the younger female from the north, and the differences between them are less pronounced. And you could see, if you're going to have time and study this in sort of a little bit more detail, you could see there's a trend. Even for the females, those little ellipsoids are becoming smaller and smaller and slightly more dispersed. And for males in general, ellipsoids are smaller and more dispersed. And again, with the age, it also shrinks and gets further apart. So it's the younger females which are the most sort of creative in some sense, and most varied, most open to influences from the other dialects, and most sort of progressive in terms of sort of language change. And this agrees well with observations by Labov and from the big studies in the US, that it's actually younger female who are driving the sound change. They are the most creative, most progressive in terms of most imaginative in terms of how they speak. So this is another type of thing, given right type of data and right amount of data, which we can potentially look at using these techniques. The third example is a bit trickier. This is an example of regional effects on realization of Swedish word accent types, so tonal patterns. These tonal patterns, in Swedish, if I understand right, are something like the pitch accents in Japanese we were talking about. So Swedish is a little bit tonal language. They have some tonal contrast, but the tonal contrast is not sort of omnipresent. Not every syllable is tone bearing. It's actually rather rare. But some particular, so every noun in Swedish or something like that is assigned one of the type of the accents. So it's either is acute and sounds like, let's say, have a rising intonation, like dollar, or has a falling intonation, more or less, or some other type of intonation, like kronor. And the way how these type of these two different accent type templates are realized are different in different parts of Sweden. And the linguists identified 5 different, as if Torne dialects, 5 different ways how the people realize these things. For example, Swedish is, by the way, official language in Finland as well. Only about 7% of people are sort of use Swedish as their preferred language, but it's still official part of Finland. It's spoken in sort of, this is Finland, by the way, this is Sweden, and it's spoken into sort of coastal areas of Finland. But when you listen to that, the Swedish spoken in Finland sort of pretty much converted to this Finnish prosody. Finnish is the syllable initial stress, has a fixed stress pattern on the first syllable because it's predictable, not super strong. So that's why it's quantity. So that's why it's something like syllable / mora time thing, and all the words start on a high and go down. So this actually, this 0 type of the Swedish accent, of the Swedish word accent sort of template, that's primarily spoken in Finland, and that would be sort of just like dollar, kronor, no difference. And then then there are sort of these 2 subtypes, 1 and 2. The one has the acute accent falling, and the sort of single peak, the grave accent, and the 2 has the acute accent sort of rising, and the dip in the grave accented words, and there is the subtypes A and B, which are differing in timing of the given peak. So some have the first syllable, some have it a little bit later. So this is sort of theoretically unearthed sort of dialect. Interestingly for us, although what type of kind of tone the dialect you speak as a Swedish speaker is sort of kind of a little bit related to the area, but there are a lot of exceptions. As we were talking about here, you know, like people were moved from one place to the other or moved and all that. So it's sort of, they can vary from the settlement to settlement, even within the same area. So this is, of course, there is a pattern, but there are many exceptions. So these are different types. You can see that there are this triangle type here, or you know, these type of type marked by crosses is spoken all the way down here, and even in this island here, and it's all sort of a little bit mixed up. So what we were interested in is this sort of language, is this sort of linguistically, and we have a database, and for each particular area, for each particular recording site, some linguists said that in this particular village, this is the accent type they use. So we were interested in, is it sort of, do the recordings kind of corroborate more this accent type, or are they more related to regional variation? So do people speak more like the linguist would tell them, or do people speak more like the neighbors, essentially? So we just, again, this was a different type of methodology. This is WaveNet embeddings. I will maybe talk about that on Thursday a little bit. But this is actually the method which uses generative sort of synthesis-like approach and extract the information through some sort of conditioning embeddings. Don't worry, we'll cover that. So it's a different approach than this sort of analyze, the Autoweg is sort of purely analysis-based and sort of kind of classifier-based technique, while this is a generative-based technique. So we create a synthesizer and look at the guts of the synthesizer, how it represents different variations. Advantage of that is that we can feed only prosody here. So this particular method did not use any segmental information, purely prosodic information. Purely F0 and intensity, as a matter of fact. Nothing else. And we use this sort of subset of this kind of rather big Swedia, the Swedish language database, which was we used something like, it was a word list actually, which we used. We analyzed something like 25,000 words or something like that from 104 locations in the Swedish-speaking areas in Sweden and Finland, essentially. And the results are like this. So this is a dendrogram. Again, don't worry. Again, there is a link to the paper. It's a rather older, actually, work. link to the paper here, and you can essentially see that, you know, this is all the possible combinations of the some sort of area, geographic area in Sweden, and the accent type. So the accent type 0 is only spoken in Finland and Åland, which is this island halfway between Finland and Sweden. But there are some accent type 1b is, for example, spoken in 2 areas. 2b is spoken in 3 areas. So we found all the combinations and wanted to see whether this will sort of be lumped geographically. So will we get the split based on geography, or will we get the split based on the accent type? And what we got is something in between. It's actually scarily perfect, the splitting. We quadruple checked the methodology, whether we didn't do something wrong, because it's too perfect. But we are quite confident it works. And you can see that actually the recordings, or the patterns, were split primarily based on this major accent type, 0, 1, and 2. First split is between 0, this non-distinguished accent types, and these more melodic ones, and then the melodic between 1 and 2. But within these groups, within these sort of major accent types, the things are organized geographically. So we don't have 1A and 1B branches, but we have the Svealand and Götaland branch. Here we don't have 2A and 2B branches, but we have Svealand, Norrland, and Götaland. These are the regionals. So it's something in between. So the way how these prosodic patterns are realized is something between so the major accent type are distinguishable, but within the major accent types, geography dominates. So you speak a little bit like the linguist tells you, and a little bit like your neighbor. The last example is, sorry, I'm just going to take a little bit of a breath and check what time is it. Oh, cool. Last example is the data-driven analysis of some Assamese recordings, which were provided to us kindly by Lina and Priyankoo. So, and essentially this is somewhat similar to the world languages. So the question is how related might be the different dialects of Assam, of Assamese. We got sort of recording of sample speech, the north wind and the sun, unsurprisingly, from different locations in Assam. Ask Lina for the details. I just got what we just analyzed what we got. And when we use the same analysis as for the world languages, so Vahtuvek and some other things, which the methodology which we will use later. So this is again, we have recordings from about 60 sites around, and from each site something like 10-ish speakers more or less, and kind of males and females reasonably well balanced and all that. And we chopped those recordings based on sentences and then performed the analysis. That's what we are planning to do, by the way, with your data as well, later today and on tomorrow and on Thursday. And now I'm going to show you dendrograms mostly. And I don't know, we've been with Tuukka and myself, we've been trying to get to familiarize ourselves with the map of Assam, but I'm still quite lost in terms of the names. So whenever we generate the dendrogram, we have no clue whether it's good. So we take Google Maps and check like which of these these towns are indicated to be close. So I go and ask Google Maps to find me the driving directions from one town to the other and check how many hours it would take, you know. It's very frustrating when you get these sort of predicted very close and then the driving distance is 14 hours or something like that, you know. I guess in Nagaland it would be sort of still quite okay, but yeah. So so this is the dendrogram we got. I don't know, can you see these labels here? I let you, at least the sort of Assamese people and people who know this area well, to check whether it makes sense. First of all, let's have a look at this split here. This is the major split between the data. So I would have hoped that these are primarily sort of lower Assamese locations. What is it? Dubri, Barpeta, Darapur, Nalbari, and things like that. That they should be, hopefully, if all goes well, mostly lower Assamese locations. And these from up to here. And these would be probably more upper Assamese. Central and upper, yeah. Now, you can see that in these sort of major splits, 1, 2, 3, 4, 5. So there's a first split, then this is almost identical, sort of there. And this one, first split, this sort of lower Assamese or Western Assamese locations are split to 2 subgroups, and these are split to 3 subgroups. And these subgroups are sort of colored. And we can put those colors on the map of Assam here. So these are there should be 5 colors. 1, 2, 3. Oh no, we only have 4 colors. So just it was my mistake. We can choose how many colors we want. But anyway, so it looks that these are 4 colors, so split somewhere else. But you can see that it actually makes sort of geographical sense how this thing goes. There is one notable exception here. That's the town of, which one is it? Yalakipur. And there is a little bit of a mistake in metadata in the date, because there are the 2 towns in Assam which have almost the same name. And when we were processing them, I think we dropped something, so this actually has the data, also contains data from some other part. So even this kind of head-scratching outlier has this type of explanation. This is a very instrumental explanation. Whenever you see something too good to be true, or really too bad to be true, investigate further. Very often you find some reasons for that. For us, sort of kind of people who deal with behavioral data and this messy data, too good is probably even more scary than too bad. Too good means that, there might be something. I'll talk about that actually, try to remind me. I'm going to talk about database. I'll give you an example of a too good thing. Now, yesterday I also used so this data, these results, are based on these wave-to-wake embeddings, which we don't know exactly what they contain, but certainly they contain some prosodic information, but they also contain some segmental information, maybe some overall, the forming characteristics, some phonotactical information maybe, what things are, some rhythmic information, all of these things. We don't know really precisely what drives these distinctions. So I kind of thought that, that when I was showing you the Swedish thing, the Swedish accents, we have this other method which you can sort of really pinpoint and make sure that you are really only talking about the F0 and intensity patterns. So yesterday I used that to the same database. This is unfortunately very small database for this type of analysis. So advantages that I trained it in like 15 minutes or 20 minutes, the thing, and then plotted something. So I trained it 3 times. So I have 3 takes on that. So, but I didn't have time to kind of put it on a map. So I don't really know whether it works. So I leave it to you. So this is the same data with the different type of method, purely on prosody. And this is the first dendrogram. Does it make any sense to you? It might not make any sense. I know because I checked locally, so there are sort of massive discrepancies. But whether there is any hint of anything good. I can show you a second take on it. And a third take on it. So you can see that every time I train it's slightly different. This is a sort of one thing that when we use these pre-trained things, then we get the the process is sort of deterministic. Whenever we run it again, you get exactly the same thing. While when we train our own models, then every training yields a different things. So I'm not sure whether this is any good at all. Now remember, this is purely on prosody. That means it's really relatively little data. And of course, also the recordings, we didn't prune them. There are a lot of hesitations and things like that. So some of these similarities might be driven purely by that, for that area, arbitrarily, the people which were recorded were slightly more hesitant or whatever. So this might dominate the things. And as I said, like having 5 speakers from each area or 10 speakers, for this type of method is very, very little. But we will try it also to train it on the database we create today, and we see how it goes. It's going to be, yeah. So yes, so this is what I wanted to show you now. So let's now take a little break. What time is it? Do you have any questions, of course? This is... There's something beeping here. Any questions? Any ideas?
I have one question. When you train the models, did you provide any context to the model about the data?
So, when I trained this particular model, I also provided the gender and the given sentence label. So I trained, we will talk about this in more detail on Thursday, but I trained sort of 2 different vector representations. One is the vector representation, or embedding, we refer to it. One is a vector representation of these recording sites. And in parallel, I gave the synthesizer the knowledge that this comes from a male or this comes from a female, because the pitch, you know, is kind of big different, and which of the 5 or 10 sentences this type of a thing comes from. So it got this type of a context. And it sort of stores these different information then in 2 different vector representations. And the idea is that, you know, we have one which is of interest, this dialectal thing, and the other one which we call normalization embedding. This is the one which actually doesn't interest us, it's a source of variation which doesn't interest us for this particular research. So we hope that all the information the synthesizer needs in order to do that goes there and only keeps the relevant information in the other one. By the way, this is because the sentences are so long. Maybe if we process the database further and had something like word, for example, level annotations, so we would give it the word identity. So the synthesizer would kind of concentrate on the smaller chunks, like with the Swedish thing, smaller chunks where it takes the different, you know, that doesn't have to kind of memorize the entire sentence as it were, but the smaller bits, then maybe we would get sort of cleaner results. We'll see how it goes. By the way, this technique works also for these sort of more localized analyses. Jeanne, who is here, she remembered that a couple of years ago in Helsinki, we actually used a very small data and analyzed some tonal realization in, actually Angami, was a standard Angami spoken in 3 different locations. No? It was in Jotsoma, Kigwema and Kohima. And we got some meaningful results in terms of how tones are realized in these different areas. And it was a very small database. Again, we had like 5, 6 recordings for each or something, and maybe only 2 or 3 from Kohima. But it's so if you have a very targeted question, this technique might yield very good results. These are maybe a little bit too broad a question for this type of a technique. Any more? Cool. So let's take a break as scheduled. We are, I think, bang on schedule. So 11 o'clock, I guess, we continue. Is that correct? Is that what the schedule tells us? Yes. Cool. If you have any questions, of course, feel free to come. I'm not going far. Second morning lecture. Today it's sort of more of a hands-on day, so we don't have huge amount of theory. Let's wait. Oh well, people are more or less here. I don't know. Is the recording starting? Can we go? Okay. So, welcome back. Hopefully refreshed. I said earlier this morning that welcome to our online participants as well. I mentioned earlier this morning that today is mostly the database day. It's a big day, the day, because the database, we hope we'll have Corpus tonight, or tomorrow, or whenever we manage to put everything together. So now in my sort of second lecture today, I want to talk a little bit about sort of corpora, corpus structure. What type of a database? What do we have to a little bit think about when we prepare a database, or when we have a database and want to use it for some particular investigation? Because of course there are two types of databases. Some of them is which we create ourselves, record. The databases for these typological analyses are expensive and tough to create. Lina would probably can give us some stories about the effort kind of needing to go to these type of things. Recording is one thing, of course. Processing, metadata, labeling, annotation, all of this it's a lot of work. It's very, very time consuming and eventually expensive thing to do. And but of course there is a lot of data out there. There is a lot of speech out there. So there are other type of databases where you can sort of crawl essentially some internet, some podcasts or whatever, in theory, and gather data. That's also very difficult because you have to have the sort of technical knowledge to do that. And I guess the most difficult thing about this type of a crawling thing is are the legal issues. The privacy. You have to be well aware, you have to be technically skilled to be able to check all the licenses, whether you actually can take the data, what can you use them for. So it's a sort of logistic and legal nightmare to do something like that. Luckily, not everybody maybe is so prudent. In particular, big corporations, they gather all sort of databases in one way or the other, and they have the legal power to fence the potential issues. And some of them share part of the data. So for example, we're talking about the Mozilla Common Voice database. That's a proprietary database by Mozilla company, but they share it for academic purposes. There are many other databases like that. Usually these databases are designed to be used for speech synthesis or speech recognition very often purposes. There are some sort of differences between the databases which are used for speech synthesis and databases which are used for speech recognition. There are different requirements. Nowadays, there is this overreaching requirements of a lot of data. So nowadays those databases are sort of a little bit merging, because essentially for speech synthesis you would want decent quality data from maybe one or two speakers and plenty, and necessarily not hugely varied. While because you want to produce one good voice and allow it to do all sort of controlled variation of the speech, while for the speech automatic speech recognition you want as diverse data, as many speakers, maybe less material from many speakers, because you want to make sure that your system covers all sort of potential issues. Many voices, it can recognize speech from many people, recognizes speech from uttered in all sort of environments. So you might want some noisy data as well. You might want loud data. You might want people crying and what have you. So there are these differences between the type of database we might need. But nowadays, essentially, you need most data. So for synthesis, because we nowadays usually build synthesizers routinely, which speak in many languages, many voices, many styles. So the ASR databases are just fine for synthesis recognition. And a lot of synthesis databases are gathered with the variety in mind. So then they can be used also for the um, recognition purposes. So today what I'm going to be talking about, I'm just going to talk some basic characteristic of speech corpora. This is by no means exhaustive lecture. There are some things which kind of came in mind with these particular techniques we are talking about, and we can be open for discussions. If many of you have some experience with collecting data, all of that is very, very interesting and relevant. A little bit about the recordings and metadata primarily. So I'll revisit this concept of sources of variations, what sources of variations there will be in the database, and what type of variation we want, and what type of variation we might not want necessarily. And then I will talk a little bit about the balancing the data, the concept of balancing the data and representativeness of the data. So, what is a speech corpus? Is it just a collection of recordings? So if we have, like some cloud server somewhere which contains 100 hours of recordings of some sort, can we really call that a speech database or speech corpus? Well, not really, because we don't know what's there. So the corpus, the bunch of recordings become a corpus or database only when we know what's there. So let's say that a bunch of recordings becomes a corpus when we have recordings and metadata. We have some meaningful characteristics of the recordings. The metadata, of course, have to contain the things which interest us, which is relevant for our research question potentially or technological application we are building. And of course, then the corpus can be turned to a database when we process those recordings and we extract some particular characteristics, some particular features which might interest us. So there are several, this is again not an exhaustive list, several sort of types of recordings. I was talking about that a little bit. So there are these sort of controlled type of recordings. As phoneticians, this is usually for the standard phonetic analysis, this is the sort of bread and butter of our life. We create these controlled, maybe small databases of some speech recordings. We often carefully design phrases. We're interested in angami tones, so we create some sort of word list or some short sentences which contain all the tonal variation. If there might be some Sandhi characteristics, we have to make sure that all of those combinations are there. We take some representative speakers, we input them into the nicely controlled environment and tell them to read something, or we tell them not to read something, or anything like that, But there were very many speech data used for sort of speech analysis purposes are actually studio recordings. And there are different types of the studios. Of course, your studio is some kind of room, usually with a microphone of some sort, and it's kind of quiet. It's sort of soundproof, isolated from the rest of the environment. And there are different levels of this soundproofing. This ultimate soundproofing is this anechoic chamber, which is sort of designed essentially to remove every echo possible. Because of course when I speak, my voice is bouncing off all of these walls around. So when there is a microphone in the middle, we can use signal analysis techniques to actually even discern the type of the room we're recording. The small room, more sort of faster coming echo. The bigger room, more slowly coming echo. But some echo will be there, always. Anechoic chamber is this, it's this sort of room with sort of soft walls, and there may be some strange shapes, wooden shapes on the walls, which tries to deflect those echoes somewhere where they don't land back on the microphone. I don't know if you've been to anechoic chamber. I don't know if you have anechoic chamber here. It's actually rather spooky for me. When you are there, we actually do not have an anechoic chamber in Helsinki. Well, I mean in our department, but we used once or twice our kind of colleagues' anechoic chamber in Stockholm. It's sort of really strange. To me, at least, it feels sort of almost suffocating, because it's not right. You know, there's no echo. You're used to this echo. The only good feature about that anechoic chamber is that it's sort of this trampoline-like floor. You know, so I can up sometimes goes there, jump in there. But so as a phonetician, I really don't necessarily want anechoic chamber recordings, because I'm interested in as representative speech as possible. And I think that this anechoic chamber is a little bit weird. So then there are, of course, soundproof rooms, which are well proved enough, so you don't hear the noises outside. You don't hear the car traffic and whatever. Metro traffic, as we actually have it in Helsinki, running under us and all that. So that's fine. But there's not sort of necessarily super sound treated inside. So there is you feel like being in a relatively small, furbished room. There are some soft walls, so that's just about fine. It's actually quite okay. Of course, many times we do not have, if we do the field recordings, we don't have this comfort to bring people to the studio. So we have to record wherever we can, sometimes in people's living rooms, or sometimes on the street, or sometimes, around the campfire or whatever is fine for us. But we, of course, have to then live with that. We have to kind of live with the idea that we recorded other type of sounds than what we actually are investigating, and we have to sort of work with that. We can either use some signal processing technique to sort of try to remove those things, or then we might need a lot of other data, because this environment creates this source of variation, which is unwanted. So we might need some sort of varied data where we can somehow statistically remove it. That on average, this extra noise is going to be sort of zero. It averages itself out. So there are many techniques what we can do. Of course, with the speaking material, because we will end up with a relatively little material, so we want the repetitions of the same thing, more or less. Because if you're interested in some rare tonal pattern in your language, imagine some rare Sandhi pattern, and you record some random speech, it might only occur once. Even in 10 minutes, and it occurs once. So we have to kind of really build it in, create those situations. Of course, very often in this control thing, we use this read speech type of a thing. Tell people to read, they sit in the studio, and there's a screen and a piece of paper, and they read whatever comes their way. And then we click the button, the text changes, and they read the next one. Sometimes what we do is to little bit get these reading things out. Not that this is sort of perfect, but we show the text to them, in particular short sentence, and we tell them to say it only when it disappears. So they little bit memorize it, and well, I don't know how non-read speech. We of course have to always admit, because this sort of register is important. As we know, the register kind of influences all sort of characteristics of speech. We were talking about that yesterday, kind of offline together, that when Priyankoo was talking about the rhythmic characteristics of different languages, register influences those as well. We had with my colleague Stefan Beňuš, we had this paper called Rhythm and Tempo in Slovak, and we did some sort of rhythm clustering of some Slovak recordings, and we had two recordings of different sort of registers. One was very carefully read, so relatively slowly read speech, and the other one was sort of more spontaneous and really fast speech. And we run the same type of rhythm kind of matrix on these two corpora, and they clustered very differently. One clustered more or less with the syllable based thing, which would be kind of received knowledge for Slovak. It's sort of this Western Slavic language with the word initial stress and all that. But the other one clustered with the sort of stress time language. So all of these are a very important thing to kind of control and to be aware of what you are doing and report it. When you have only the read speech, one paragraph, like we will have today, we cannot say that we have sort of analyzing speech, it's only its variety. We're analyzing this particular register of speech. Of course, there are other type of things like spontaneous speech, of course. We can, in theory, not in practice, but in theory you can put a microphone somewhere and let people to talk. In practice you cannot do that. You're well aware of that. So, but we can of course get people to the studio sometimes and let them to talk together, and let them, if we have a lot of time, You know, if after half an hour the students of similar age, even they don't know each other, they will start talking, of course. Again, we lose control. We don't know necessarily what they are saying. Of course, we can prompt them. I talk about childhood memories or whatever. So we can prompt them to get roughly the area like that, but we get sort of more spontaneous type of speech. Or we can tell them to retell some story, you know, read something, we talk about something else, and then what was there. So then we control it a little bit more, and it's more spontaneous. Of course, in the sort of unscripted dialogues, usually our experience is that, not always, but very often, one person is more talkative than the other. So we get like 80% of material from one person, and from the other sometimes just, oh, you know, like that. But of course, we have to live with all of these type of things. To sort of elicit a little bit better data, which we can control this degree of sort of how much people speak, there exist all of these sort of game-like tasks. You know, that usually there are these sort of, that we put two people in a studio. Sometimes in Helsinki, for example, we have these two booths which are isolated from each other, sound isolated, but there is a window between them. So we can record two people communicating, and we don't have this sort of, we only have one person in the microphone. They hear the others through the kind of well-insulated headphones. So we can get them to play all sort of games, you know. Like the map task game is very typical that, you know, you get somebody gets, both people get sort of a map of some area, as it were, and when there's some objects, for example, and one has a path drawn through that. And then the one has to kind of communicate that path to the other who is following that, and they have to communicate. And of course, if we want a little bit better communication, we can have those maps not identical. So somewhere somebody has this tree and the other one has the house, and it goes like, oh, that is a tree, you turn left, and it's like, there's no tree. So, oh, what do you mean? There is a tree. Where are you? You know, that type. So we can elicit these type of things. One of our students came up with this idea that people, we let the people to play Sudoku together. So they had the Sudoku, both of them, and they had to kind of do the Sudoku together. But the Sudoku had some pieces where some squares were only present on, they were not completely identical, so there was missing information in these two Sudokus. So they had to kind of communicate. That worked quite well, for example. Particularly people get kind of competitive, and they start, you know, competing and going there. Of course, there are all sort of things in between. Like there are things like, you know, radio plays, podcasts, you can get, I guess they are somewhat, of course they are not really scripted. Well, radio plays are of course kind of fully scripted, but they are then performed by the actors who are pretending that they are not fully scripted. Then there are podcasts which are not fully scripted, but then they are done by these professionals who have their mannerisms, so it's sort of little bit repetitive. So there are all of these type of things in between. Of course, very often for example, speech synthesis corpora, unlike speech recognition corpora, we use actors. We use trained actors to record the corpus, because we might need something like 20 hours of recording from one person. And that means that, you know, we record it over several weeks, because you can, usually the rule of thumb is that you can use roughly half of what you record. The rest is like, you know, coughing and repeating and going like, oh, sorry, I messed it up, or, you know, don't worry, you know, take your breath, I'll have a sip of water, that type of a thing. So half of that is sort of the usable speech. And of course, and you cannot really lock somebody to the recording room for 8 hours a day. So maybe like 2 hours in the morning, 2 hours in the afternoon. So, you know, you do your math, how long you need to record that. And the person like me, who is not a trained actor, or whoever is not a trained actor among you, is not very good at sort of coming the following day, you know. You then go from the studio, pick the children from the school, you know, and kindergarten, and cook the dinner, or go out. And then you come 10 o'clock in the morning back to the studio, and you have to continue with the same voice and the same level of tiredness or whatever as the night before, as the evening before. And most of us who are not trained cannot do that, really. You cannot feel. Actually, we recorded one of the sentences I played to you from Martti Vainio was actually part, the one which I used the voice source, was actually part of the early corpus of Finnish speech, recorded by the phonetics professor nowadays, Martti. And he's not a professional trained actor, although his wife is. And it was when we analyzed it at some point, you could really discern the Friday recordings from Monday recordings. You know, even sort of signal analysis wise, the pitch was way lower on Fridays than on Mondays. But of course, these actors, they get into the role, so they create for themselves a persona, and then they are capable of switching straight to that persona. So they are not necessarily themselves, but so they can be super consistent across long periods of time. Of course, the downside with the actors is that they have this mannerism, of acting mannerism. You know, there is some particular, they are trained to perform in some particular way. They are trained to perform emotions in some particular way. They are trained to read the narratives in some particular way. You know, so it's a, for example, when you try to do some emotion analysis of the data, very often people use actors, but then what you actually analyze are the acted emotion from the particular school of acting, which might be different in Europe, might be different in India, might be different in Japan. So there are these mannerisms which the actors use on stage to communicate I'm sad. So these are all the downside of this sort of semi-spontaneous kind of type of information in corpora. Again, there is no right answer to which corpus to use. It completely depends on your research question. And very often we cannot really afford or have no time to kind of record the new corpus we need. So we have to do with something which we find. You know, every sort of phonetic department has some stash of recordings of some sort. So you know, there is usually students get something which so we have to do with that very often. Of course, there are many sort of sources of variation. I'm going to be bringing this word back again and again. Sources of variation in the recordings. Something which sort of interests us is the type of the sort of language, the code essentially, or something what people use. You know, so for example, will the people record the thing in the sort of standard language? Language as such, like sort of the language which comes with a label, an ISO code, tends to be a political creation. So it's some agreement among some sort of group of people, some policy, that we will speak like this when we communicate with each other. And usually it's sort of enforced by education and sometimes in some countries by sort of policing even, that, you know, oh, this cannot have this sign because that's incorrect language, you get a fine, something like that. Mm-hmm. So people usually do speak the standard language, but of course this depends on the level of education, level of exposure to the standard language and all that. Also, the standard language is a little bit, because it's a sort of political creation, a little bit abstract concept. So everybody, even their standard language, which they were schooled in or potentially grown up with, we all speak it with some particular dialect or some particular accent. Well, not necessarily dialect, but some accent. Like even when I speak standard language, people in my mother tongue, Slovak, people can tell I'm from Western Slovakia as opposed to Eastern Slovakia. That's how, you know, however hard I try. So it's even that sort of, even when you have a bunch of recording in standard language, you have to be aware that they are not all the same, of course. People will sound different. Of course, then we can, what we want to record, many of us, what we're interested in, is to record a dialectal speech. That's a real thing. That's how people really speak. It's not sort of necessarily the political creation. This is the means of communication, dialectal speech. But it's kind of tough to record dialectal speech, precisely because of all these sort of influences of the standard language and prestige and all of that type of things. It's actually super difficult to get somebody on the street, put them to the studio and tell them to speak in the dialect. People don't want to do that. People, you know, either there are all sort of possible options. People sort of simply speak standard language as much as they can speak standard language, or then they sometimes do this kind of cartoonish form of the dialect. They sort of exaggerate some features. Sometimes, I don't know, in some countries, I don't know whether, like in my home country, there is a very big, strong dialectal variation, geographical east and west. Actually, the standard Slovak is the quantity language. We have long and short vowels only, not consonants. And it's the sort of the first syllable stress, fixed stress language. But Eastern Slovak is a non-quantity language. They don't use quantity, and they use penultimate stress pattern. So this is a big difference. Prosodically, it's a very different language. Well, but then there are, because you know, on TV there are these comedy shows or whatever, or they want, again, these actors want to mark that somebody is from the East. So there is this sort of mock Eastern dialect. And bizarrely enough, very many of the people from the East, when in studio, they kind of convert to this thing what they think that the researcher wants to hear, as opposed to the ways how they want to. So it's really tough. I guess really you need sort of, I don't know, I don't have huge experience with the field recordings, but given in a field recordings, it must be really difficult to tell people to speak dialects. This is a huge challenge. I have no solution to that. Maybe if you let people to speak a lot, maybe they will eventually kind of converge to the. We have with my student, we did some Slovak recordings. Monika, who was here, so Slovak recordings, and we let people to read from all parts of Slovakia. Read them to read actually this rather engaging and sort of quite shocking story, which was like, I don't know, 3 pages maybe story, so rather long. And you could see how, because it was rather engaging, the story, it was read speech, you could see how they went to the dialect on the second page, because it was sort of interesting story. So they kind of forgot a little bit about what they tried to kind of communicate, and they really, so there are tricks, but I don't know, it's not easy. Of course, then there are all sort of other things like accented speech, like foreign, you know, different accents on L2 speech, you know. I can record myself speaking English, and one can look at what does it mean. How does Slovak speaking English differ from the Indian speaking English, or you know, native speaker and all that. So there are all sort of other possible combinations. We are interested in all many things. Again, when we record this accented speech, that's kind of also difficult because people either refuse to record something in the language when they are not super confident, or they sort of underestimate their abilities, or they overestimate their abilities sometimes, and they say, sure, I can do that, and then you realize that actually they don't. You know, so they're all sort of, and because we need the metadata, we have to record all of these possibilities. We have to be aware that when we throw that data to the machine, we have to be aware that what comes out might or might not be representative. So those are all type of things. Of course, we were talking about this a little bit, about the recording quality. Again, depends massively on the question. We actually talked about the difficulties in the recording speech materials in the all type of studios, on the street, in the, you know, many other conditions. One thing which has changed in, I wouldn't even say in my lifetime, but in a small portion of my lifetime, is that that everybody nowadays has the recording device on them. You know, this, to your surprise, this was not normal 20 years ago. You know, nobody had a recording device on them. You know, nowadays you can actually ask people, like we did, you to record yourself. Of course, the computers can record, and even computers were not routinely equipped with mics until 10 years ago or 15 years ago or something. So now that's sort of crazy. That opens up new possibilities, of course, that we can essentially ask anybody to go find some nicely furnished, soft furnished, quiet corner in their room and then record themselves. And of course, there is a huge amount of, until 20, 30 years ago, we purely relied on sort of radio. It was like a very limited amount of channels. Now there's an infinite amount of channels. There are all sort of podcasts and YouTube videos and whatever. So there is vast amount of speech being recorded as we speak. So that opens up new possibilities, and I'm not completely fluent in exploring those at all. It's left to you, I guess, to do that. So now, again, metadata. This is the very, very important part. So what do we need to store? Again, of course, this is a mantra. Depends on research question, right? So we need to store all sorts of information about the speaker. Anything which we might need for the later analysis. What does it mean that we might need it for the later analysis? Anything which is a potential source of variation. Anything, any type of information which might influence how the recording sounds. What is there in the recording. So gender, I'll talk about that in some soon. Age, when younger people sound different, of course small kids sound different, younger people sound different, older people, etc., etc. You know that there are these two different directions actually of the general voice change, and it's in terms of the pitch, the average pitch. For female speakers, there is this called postmenopausal pitch drop. So after the menopause, the pitch drops ever so slightly, but discernibly. We have many of the data where you have to be aware of that when you analyze the average pitch, and you have from one village you have only young women, and from the other village you have older women. You cannot then say like, oh, in that village they have a lower pitch than in this village, because you might have all of these things. For male it goes the other way around. I don't know, I don't think that there is official recognized menopause for men, so I don't know what the name for that would be, but there is a slight rise. A little bit less pronounced than the females, but a slight rise of the older men has higher pitch than the younger men in general. Mm-hmm. All sort of things like in the mother tongue, when we record the English data that we recorded today, of course we want to see the mother tongue of the people. Mother tongue itself is a bit of a theoretical concept, I guess, for people. This is a very Europe-centric concept. Eurocentric after Second World War concept, when Europe was, I guess, unprecedentedly divided to these small pieces of land, where everybody spoke one standard language and pretty much nothing else. So this sort of single language, and that's kind of easy to ask what your mother tongue is. Of course, nowadays, even in Europe, it's much more complicated. And for the rest of the world, I think this big chunk of the rest of the world, this never really popped up. So people speak in India, of course, all of you speak many languages. And for some of you, it's maybe easier to say which would be the mother tongue. For some of you, it might be kind of difficult to say. In Africa, it's completely out of question. Everybody speaks 4 or 5 languages, and they are used in different contexts. Even with a mother, you might use one language when you talk about cooking and the other language when you talk about schoolwork or something like that. So my daughters my wife is Finnish, so they are sort of half Finn, half Slovak. They were born in Ireland, so they are Irish citizens. But the older one in particular, went to school for some period of time in Germany. They are very confused when you ask them about the mother tongue. they sort of refuse to talk about that. Now, of course, like the domicile, where you reside, maybe some of your history when you move around. My daughters, for example, would be a good example. The first 3 years or 4 years Ireland, next 4 years Germany, the remainder Finland, something between Slovakia for a year or so. So that would be kind of interesting, I guess. Place of birth, where people grew up, social economic info. In many cultures, in every culture, there is a kind of correlation between the way how people speak and the social economic background. In some cultures, it's more pronounced than in the other. For example, British English is very sort of layered in terms of the social background. Some other European languages less so, for example. Occupation, education, name it, all sort of things. One thing, actually, as you noticed here, which you don't really need, is the name, for example, or phone number, or email address, or hair color. So there are many things you might not really require, because you don't think, well, I never thought of anybody who would kind of investigate the hair color sort of variation in speech or something like that, and hopefully I will never see anybody like that. So you, of course, you really need to think hard what types of sort of characteristics of the speaker might influence the way how they speak. And you don't really need to store the stuff which we are confident enough that they will not. Of course, then you want to maybe store also the underlying linguistic material. Text, whatever is read speech, you might want to store what they read. If it's sometimes we read these different words, for example. We are really interested in some tonal pattern in a word, or prosodic pattern in a word, quantity in Finnish, minimal pairs and all that. And we usually read them in some, so embed them in some carrier phrases, as we call them. So in English, almost all the basic phonetic material is actually not about English or segmental stuff, but about segmental stuff as pronounced in the carrier phrase, read sometime again, So we sometimes, because this can be really repetitive, what we do, we a little bit vary the carrier phrase. So you might log, for example, what carrier phrase was used for this particular thing. Sometimes you might be, in particular in these finely controlled phonetic experiments, what might also be very super useful is to log the order number of the thing, because you might very often the way how the speech is realized depends heavily on what you said before or after. Well, not necessarily after, but before. And whether it was at the beginning or at the end. Of course, if you read the list, we very often ask people to read something 10 times, and then we only use like second or third repetition, because the end is sort of boring, but first is taking a breath in. So all of these type of things you might want to log. We had this very clear example of that. We did quite a lot of research in Lombard speech. You know what Lombard speech is? The speech in the loud environment, when you speak in some ambient noise. And of course, there are all sort of relatively well documented adaptations to that. So you, of course, when there is a noise around, you shout more, but you only compensate about half of the noise. So if there is a noise of whatever 40 decibel, you only increase your output by about 20 decibel. But you also increase the pitch, which again manages to carry the voice better. And you change, remember we're talking about the spectral slope up. So you speak more like that. You put more energy in high frequencies, which we hear more. So you do all of these, and you also do some temporal variation, which you lengthen the vowels and shorten the consonants, funny enough, because vowels are good in the noise, consonants are bad. So we did a lot of the recordings, and we put some noise to the people's headphones and tell them to do something. We actually did these articulatory recordings, they had the wire sticking from their mouth, and then you put the noise out and tell them to sell something, and then you put the noise back. It turns out that actually the noise level before these particular recordings is as informative as the noise level currently. Because people sort of carry on, When you blast 80 decibel into somebody's headphone, so they shout, and then you switch the noise, they keep shouting. So this is the very sort of extreme example, but you might want to know in what order you're recording, in particular for the finely controlled experiments. Mm-hmm. Of course, some annotations, if we have them, they're priceless. Segmentation, all sort of things, we might want to have with our recording. Types of phrasal breaks, in the normal sort of recorded speech, hesitations, if we can have them, and this type of whatever we can get hands on, it would be good. Now, this is actually one of the kind of conundrums of the speech science, because we are put between sort of two millstones. There are two requirements imposed on us from the society, actually. And one is security and safety. So, they are both concerned about security and safety and actually scientific paradigm. So on the one hand, we have to commit ourselves to not harm the people who are kind enough to donate their sort of biological sample almost, as it were, they donate their voice. So, because human speech is a biomarker. Human speech is almost as much biomarker as the fingerprint. So if all of us have slightly different timbre of our voice, so we actually can recognize people by their voice, even when we don't see them. Machines can do it way better than us. So the voice, there are of course some even voice security features that you just tell something and it lets you go or something like that. So we have to minimize the possibility that this somehow leaks around, and then sort of the bad people get hands on our recordings, and then they use to access somebody's bank account or something like that with that, So we cannot, and we have to of course think about what's possible now, but we have to also think about the future. There is a sort of arms race as always between the good guys and bad guys, so all of these, whatever ways of use technological applications come, they also comes sort of misuse of technological applications. So we have to make sure somehow that we are protecting the people. But on the other hand, as honest scientists, we are strongly encouraged to publish our data, because so that we don't make things up, you know, essentially. So that we want to kind of produce the results which are reproducible, which anybody can. That's why we write these methodological sections where we say how we did that in some precise. We publish the code with our stuff and all that. So we should publish the data as well. This is a conundrum. This is a difficult one, because we can publish data, but we shouldn't. So there are many different ways how to sort of deal with that somehow. There is no perfect way. There are just sort of better ways than the others. There are some good practices, you know. So of course we want to secure the data storage somehow, so that the villains cannot just go and download them from somewhere. And in particular, the personal information. It's sort of bad enough if somebody's voice is freely available on the internet, but it's nowhere near as bad if all her or his personal information are attached to that. So as long as we manage to, so it might be okay to publish some voice samples, but it should not be traceable ideally to the people who did that, whose voice that is. If I was some villain trying to rob the banks, I would start with phoneticians, because our voices are all over the place, because we use them in all public lectures and all that. Essentially all the voices you have heard, well, you should have heard yesterday during my presentation, were some fellow phoneticians. Of course you want to obtain create some agreement with the participants. You want to obtain some written consent, about informed consent from the participants that they are happy, and they should be informed. It should be consent. They should say that they are happy. It should be informed consent. They know what they are getting into, right? Maybe sometimes what helps is to share the sort of results of the processing steps rather than the raw recordings. So for example, we might share the wave-to-wave transforms of the things heavily processed. In particular, because we are doing some particular analysis step where the processing depends on the other data. So we are doing some dimensional reduction. So it's not, in theory, I guess, the wave-to-wave can be reverse transformed, although it's a lossy transformation. So in the future, maybe somebody can find, how to recover the voice back. But because we do extra transformations which sort of depend on the full database, as it were, all the other recordings there, so maybe that's relatively safe. That's probably not reversible. So maybe something like that we can publish. We can publish maybe 1 or 2 voice recordings with it, so somebody can try that it really works. That type of a thing. Maybe F0 intensity contours are quite safe, for example, to publish. So these are difficult ones. Now, by the way, I'm talking about that, and you should be thinking, oh, well, but this guy wants to collect our data this afternoon. Is he not the evil guy, despite. So we'll talk about that as well. We have some ideas. We unfortunately, because of the practicalities, we don't really have huge amount of possibilities to sort of write the written consent, but we will provide you several possibilities how to share the data with us. So the base, we will sort of maybe create, 2 guys working on that, create some Google Drive where we can sort of maybe upload your data if you want. But of course, by definition, because uploading is going to be visible for the others. But if you don't want to do that, you can just send the data to us in some particular way, and we will only publish we will process the data in terms of these embeddings and what have you, the WAV2X, and then we only share with the others those things. But we can talk about it in the afternoon when we are preparing the database. And we will have this we will create this metadata thing where you fill in, But of course you fill in only the information you want, and you are absolutely, this goes for the online people, you are of course perfectly free to withdraw your participation in that. It's absolutely fine. There is zero repercussions. We will not figure out who did that. We will not try to match and punish you somehow. Not at all. Not at all. We are the good guys. Of course, one thing which is something which we should always try to think about is how can the research we are doing sort of benefit the community. This comes very often, this comes as a question very often in particular sort of minority language setup, because there are all type of sort of relationships between the, let's say, majority and the minority, and very often it comes like, well, why would I do that? What is the benefit for me in that? We in Finland, we have this relatively small indigenous population, the Sami people who live in Lapland in the very north of Europe. That's apparently the only indigenous peoples in Europe left. And they, historically, the experience of that community with the sort of majority peoples like the Finns and Norwegians and Swedes and Russians is not necessarily very positive. And I'm putting it mildly. There were a lot of kind of nasty things being done to the community 100 years ago or so. Nowadays, of course, it's a very interesting community, and we as linguists and everybody else wants to sort of get the data, you know. So we had actually, we're recording one Sami student, a young woman, and she was a little bit late for the recording, and she apologized. I'm sorry, I'm late. I just came back from the hospital. I was giving my DNA, you know, for some other research. So, you know, they might feel themselves as sort of, you know, and we get it very often from them, like, why would I do that? Like, you know, I don't owe you anything, and how will I benefit, or my community benefit from that? So do you have to be ready for these type of questions, and or not, and then you say like, actually, I just need my PhD, and you know, please, you know, something like that. There is also the level of anonymization which might be relevant for some North Indian languages, because we published this paper with this was very fine, actually, articulatory analysis, so very little sort of speakers, but it was because we were looking at this areal variation, so we needed a publication to publish the, you know, some meta information about the speakers, you know, the gender, the location where these people sort of spend most of their life, and we did some age-related analysis. So we published these age groups, and the reviewer asked, like, we would be interested. I want to see, could you publish the age at the recording rather than age group? We published these broad age groups, but we said sorry, we can't, because then the person will be identifiable. These are very small communities of, you know, these actually, some of them are even sort of little bit nomadic communities. So these are very small communities, you know, of maybe 50 people. So if we say that it's a, you know, 54-year-old woman from that village, everybody knows who she is, you know. So those are the things which we have to kind of consider sometimes for the. I prepared something actually. This is I will acknowledge it hopefully in the version which I share with you. This is some guidelines for informed consent coming from the University of Massachusetts Amherst in the US. So this is a little bit sort of US based consent, but because in US the legal kind of environment is so strict that it's good to look at what they have, because they have to have all of the corners covered. So this is in some sense sort of almost maximal level of protection. Of course in Europe we have the GDPR type of things, what is it? That's sort of the Data Protection Act. So I don't know, if you are in Europe and you open any website, you have to kind of accept all the cookies and what have you. So there is a direct legal protection of the thing. So we don't have to specify everything, because many things are by default that we cannot share that type of information and all that. So, but anyway, these are some sort of questions you might want to consider when you are sort of recording the data. Keep looking at them a little bit. I'm gonna sort of check what time is it and take my breath. Let's have a 5-minute break, and then we can go through this. Tell me about it. So, okay, we can maybe slowly continue. So these are some points, as we were saying, about what type of information we might want to provide and what type of information we might want to require in the sort of informed consent. By the way, I was talking about my own experiences in the sort of all type of phonetic and speech recordings. I'm sure that you yourselves, between yourself, have many more interesting sort of experiences. Many of you have recorded more of the dialectal material than I ever attempted. So please feel free to share them. We can have the debate at the end. I guess all of us are very, very interested in these type of things, to maybe avoid some potential mishaps in the future or learn from the best practices. So maybe at the end of this talk we can not only ask questions, but please share your own experiences with the others. So back to the informed consent. So we might want to ask these type of questions. Who is eligible to participate? So it means that we might want to specify in the informed consent some sort of limitations. What we actually require from the speaker. This is when the speaker would sort of or the participant would sort of a little bit commit herself or himself to kind of, oh yeah, I fulfill. Usually we very standardly want some, no history of hearing and speech sort of problems, and that you are really speaker of the language, all those type of things, We might want to tell the participants, what is the purpose of the study. That's an informed part of the informed consent. They should know what we are after. This can be sometimes tricky. Usually in our type line of research, when we do some phonetic stuff, we can be reasonably open about that. Although sometimes when you want to investigate something like, tonal things or quantity, and you tell them that you're into the quantity, it might sort of put their attention too much towards that, and they get sort of exaggerate whatever things. So, of course, we did also some sort of psychoacoustic experiments, when you essentially try to trick the people a little bit. Very often these psychological experiments, it's tricky. You might even tell them, I'll tell you at the end, You might debrief people. But you might need to sort of couch it in the phrase, which is true, but is not harmful for the study, essentially. Because you should tell as much as you can, but of course sometimes telling everything would sort of ruin the study. Of course, where would the study take place? How long will it last? So you should commit to these type of things. So so that you don't trick people to come somewhere, kind of pretends that they're going to take 5 minutes, and 8 hours later they are still recording. We do that sometimes with ourselves, like we had this, I did in my past life as a phonetician, I did quite a lot of articulatory recordings. I don't know if you know the EMA machine. It's you glue these sensors to people's tongue and lips and inside, and then there's wires sticking out. And there is some feedback going around here, by the way. So we apply, and you cannot really torture people. It's not painful. It's not nothing. We're just very uncomfortable. In particular, sitting in this boot, attached to the machine, so you can't really go out. You can't really go to the bathroom, for example. So with the subject, like we kind of limit the study for like 2 hours or something usually, But ourselves, when we did record ourselves as phoneticians, 8 hours, 10 hours, somebody walking with a machine to you with a bathroom, so, but normally you should not do that, of course. But of course it also has the repercussions on how people get tired and all that. And you should tell them. You should tell people what they will be asked to do, in advance. So they should know that they're going to speak on a microphone. And if you want to give them electroshocks while you're doing that, you have to tell them that it's going to happen. So, of course, this is a tricky one, What are people might be interested in hearing? What are the benefits from doing this study? So this is what we were talking about earlier. Sometimes some particular, in the medical research, for example, there might be some potential benefits. When you are exploring some new drug and you suspect that this drug might work, you might say it might actually heal you, as a matter of fact. In our field, this is trickier. Sorry, can you switch one of the mics around off? It's this one. This was sort of interesting. I was standing here and that was sort of interfering, and it was interesting speech adaptation exercise because I tried to speak the way which wouldn't interfere. It interferes. They are recording this kind of. I want them to ski. Can you switch this mic off? Because I get a feedback here.
Okay.
I have this mic is on.
Actually, it is a dynamic mic. It's not captured from distance.
Sorry?
Yeah.
Yeah.
Okay.
But I get this feedback loop
Oh,
here.
actually,
Yeah.
yeah.
Okay. Let's hope for the best. So so what are the benefits of somebody being in the study? So this particular form from the University of Massachusetts provides this helpful suggestion of formulation, something like, you might not directly benefit from the research, but we hope that participation may, and then we want to be as honest as we can. Maybe we can help your community or can help preservation of your language. Sometimes we record the databases of the minority languages, Sami, for example, for the speech technology applications. So actually they would have the access to the speech technology in their own language, which of course then has repercussions in order to sort of preservation of the language, because the young people then can actually use the machine technology in the minority language rather than majority language, and young people use the technology a lot. So if they spend half of their time using technology in the Finnish, they are less likely to then speak Sami than if they can use the technology in Sami and things like that. This is very important. What are my risks of being in this study? This is the very important informed part of the consent. Normally this has been kind of thought of when this type of informed consent protocol was kind of introduced in academia, and this was actually introduced in sort of between 1940s and 70s in Europe. Tragically, the source of this type of informed consent idea was a consequence of the atrocities during the Second World War, where a lot of prisoners were subjected to horrendous treatment, and this was actually part of in Europe the sort of after the war was this Nuremberg conference where all of these sort of issues were being discussed, and this is direct offspring of that thing. So this is so what they meant at the beginning. What is the risk of my study is that you are going to die or something like that, or you are going to get hurt badly, or whatever. Something might fall on your head. So that's usually, luckily, not the huge risk in our case. Our studios are reasonably well sort of built and screwed and all that. But of course now there are other risks we are talking about. And people should be aware of that there is a potential risk of compromising maybe some privacy or something like that. And of course, then we have to say, how will my personal information be protected? So what are we doing in order not that to happen? Of course, people might want to, this is a contract of some sort, signed by all of those people. So people might, want like, will I receive any payment for taking? So that's of course gonna go there. What if I have questions? What happens if people have questions? Maybe we can specify that. Not all of these points, by the way, are mandatory. This is a sort of wish list. I can hardly imagine the sort of situation when, what if I have questions? I don't know what I would actually put there, honestly. Now, this is a very important. Can I stop being in the study? One of the sort of principles of scientific research is that the participation is purely voluntary. And that means that participants can quit at any moment without no repercussions. Which means that, in theory at least, I guess kind of cultural habits kind of prevent this happening very often. But in theory, you are supposed to pay the full fee, even if the person quits up immediately at the beginning, because after the contract has been signed. Because otherwise, you are sort of creating a power position, and you are sort of forcing them, potentially doing something which is uncomfortable for them. This is very important, and they should be informed about that. That you are willing, you are perfectly fine to quit any time with no kind of repercussions or no bad feelings. This, by the way, goes also for today's sort of thing. When you can, if you put the data, you share it with us, you can always tell us to remove them anytime. If your point is sort of showing as an outlier somewhere, no. So, and here is the last sort of bits I directly copied from the University of Amherst, University of Massachusetts in Amherst information. These are some suggested statements. And when signing this form, agreeing to voluntarily enter this study, I have a chance to read this consent form, and it will be explained to me, and was explained to me in a language which I use and understand. This is also important, that in many relevant situations for us, this might be something very important, that you don't read something fast in English and hope for and assume that people have understood what was explained to them. I have had the opportunity to ask questions and receive satisfactory answers. I understand that I can withdraw at any time. A copy of this signed informed contest has been given to me. And then you can sort of put some such, these are suggested statements. I agree that segments of the recording made by participation in this research may be used for conference presentations as well as education and training of future researchers practitioners, for example. This is something we might implicitly think that you will consent to today. Maybe not conference presentations, but for the training of you at least. Or academic purposes, sometimes we put this type of a phrase. Sometimes we also say the phrase that will not be used for commercial purposes. So we commit ourselves not to sell it ever, or give it to some institution or company who might kind of rake benefit out of that. I agree to have my recordings archived for future research in the field of dialogue studies or dialectology. This might be kind of interesting. This might be something useful, So you give a consent because you are told that this is going to benefit your community and a particular sort of dialect, but you don't want that data to be used to study speech impairments or something like that, or study whatever fine-tuning speech synthesis stuff. So you might kind of limit your the field within which you're actually consenting to be this data to be used. So you don't want Facebook to train their systems on that, or even academic institution to train their synthesis on your speech. You just want really them to use it for the dialectal studies, for example. I do not agree to allow segments of recording participation in research to be used for conference, presentation, education, and training purposes. You might have these tick boxes, and the person can sort of pick one. Something like that. Of course, these are just guidelines copied from somebody. Different legal systems require different things, different type of formulations are used in different cultures, the language of the consent form might need to be adapted and all of type of things. Of course, so many institutions provide their own sample consent forms. I don't know whether IIT, in general IIT Guwahati has one. There are ethical committees and universities, they might have some say on these consent forms and all that. Now, so let's get back from these sort of legal things to sort of the way how to design a database, what to think about in the database things. So these are just some examples. I was kind of talking about these sources of variation. So let's kind of a little bit zoom into those sources of variation. So this is, I just tried to a little bit limit here, put here all sort of influences which give rise to this diversity, to name them. So we were talking about as individual, there are the linguistic, phonetic type of differences, there are the other things. So individual would be again gender or biological sex of people, age, languages spoken, social economic background, potential disorders, where they grew up, the language education, all of those things, Linguistic, phonetic, now what language the sample is in, what is the dialect, socialect, potentially, is it formal or spontaneous, sort of register, is it read, what type of, form, is it a question, is it an answer, is it Lombard speech, all of what is the environmental noise around, all of those type of things. Potentially, we phoneticians very often sort of forget that's how obsessed we are in how people speak. Potentially even something, what are people saying, that also is a big source of variation, I guess, in speech. And then there are the other things like recording conditions, like mic type or sampling rate, and all of the other sort of post-processing steps, like, has it been compressed, has it gone through the MP3 stage at some point of its life, has it been somehow filtered or something like that. So all of these are sources of variation. All of these influences make a difference in how the speech recording actually sounds. So there are some sources of variation which are sort of subject matter of our research, which we actually really want to investigate, and then there are the others which we want to sort of ignore, which we are not interested in. This is, of course, depending on the choice of the question. So, for example, if you want to do the purely dialect analysis, so recordings from some language, like we had the Assamese data, and we want to check how, as we did, how the way how people speak correlates with where they are from. So then only the dialect is actually what you want to have, and everything else essentially you want to remove. Everything else you somehow want to know how the dialect, what are dialect differences, regardless of all the other potential influences. So sometimes you might want something like we did in that Finnish study, Tukka's Finnish study, that you are interested in the dialect and gender and age and how these things interact. But you're not interested in whether people have iPhone or Android phone. All of those things you want to sort of wipe out. You want to treat them as some sort of random effects, as something which does not influence your results. Or I don't know, in the languages of the world, the language, assigned language of the recording, what we're interested in, and not the dialect. Like, for example, English recording in that database contained Englishes from all over the world. They are just completely mixed together. The British, American, I don't know, Tukka might know, is there Indian English among those English recordings in the Common Voice? No. You don't know, actually, yeah. These all sort of put together, so the dialect, the variant, is completely hidden from the users. So that's a source of variation you might want to try to kind of ignore or remove. Ignoring doesn't mean pretend it's not there, by the way. Ignore means do something about that potentially. Now, or maybe just region. is the interesting thing. Or any of these, there are many, you know, almost any possible combination might be kind of cool to investigate. So how can we kind of minimize the effects of the we cannot remove, unfortunately, fully the effects of the unwanted variation. If we wanted to remove the effect of the unwanted variation, we would probably need to record all people, whatever they said ever in history, you know. So then we would have the complete data and we can sort of just analyze them. That's when somebody asks me, what database do you want? I always say, I want, like from that given language, I want all the utterances ever uttered in that language. That's the first step, that's what I want. And then we have to start sort of making compromises, as you can imagine. So one thing which is relatively easy-ish to remove is the recording setup issues. So this is simple. We just use the same mic, right? It's simple at the first sight. You know, we use the same mic. We use it in a way that it should be used. We use it as our same studio or the same type of a setup. We use it as supposed to be used. Now, if we are experienced, and there are many way more experienced people than me, recording people, we might need to control how far the mic is from the mouth, roughly. How is the gain set up on the recording things. Make sure that your recording cable doesn't go over the source, which is plugged to the mains, and adds the 50 Hertz hum, and all of those type of things. This is all about the experience of the people. If we do field recordings, unfortunately, we cannot completely control all the environmental noises. We just have to then ideally, well, I'll talk about that in a second, what other things we can do. Post-processing also, sometimes whatever there is a lot of noise, so we filter, we low-pass filter or high-pass filter or something like that, or some speech recording. So we have to make sure that we ideally do it kind of consistently across all the recordings. Some sort of things like something we can kind of remove the source of variation by sort of control, imposing some sort of control on the data gathering or on the database, on the corpus. So for example, we can, as if very often we kind of control out the potential disorders. If somebody is sort of hard of hearing, that might influence the way how they speak, so we just apologize and say like, this is not, we cannot use your data in the thing. Or somebody suffers from the very heavy stuttering or something like that. We unfortunately might not be able to include those people in some sort of database which does not want to distinguish between people who stutter and don't stutter. We can of course kind of control whether we use formal or spontaneous speech and not mix them up too much, because these sort of registers make a huge difference. We can of course control linguistic material in some of the things. They all read the same thing or something like that. Form and all. Of course we can control just about any of these things. We can control, if it works like that, we can just record people from the same region. It depends on what is the situation. If there is, if there is some magical one city where all possible dialects are spoken, or we want to only look at some sort of city dialects or whatever it would be called, then we just stick to that one city and record things from there. Anything can be controlled. Control means that you are sort of trying to remove as much of variance as you can. You stick to one of those possible values of that particular variable, and you just sit with that. The other thing, some of the things can be removed by sort of signal processing and analysis. So gender, sex, for example, F0 contours can be sort of normalized. Priyankoo was talking about it yesterday when there was some Angami our tones, and they were sort of Z-scored, which means that you essentially remove people average pitch and their variance. So some of these things some of the effects of some particular variables can be removed sort of either using some signal processing methods or statistically. In statistical analysis, we have some random effect models which can sort of tell that these are the unwanted sources of variance, essentially. Ignore, in your interpretation of this data, ignore these effects and only concentrate on the effects of the interest. So, linguistic material, I don't know what I meant when I kind of marked that, but you can sort of, I don't know, delexicalize things and do all sort of other potential things. So, of course, all of this is just very kind of broad ideas and nothing kind of novel, I guess. This is sort of kind of straightforward. Just one kind of wants to think about these type of possibilities, and one wants to do it sort of correctly. For example, we have a sort of anecdote. The Swedish study, the Swedia database we used. It's, as I said, it's a rather big database, and we only use minor fraction of the small fraction of that. They have these recordings from I think 107 locations, and depending on the size of the location, they can be between, I don't know, 7 and 100 speakers. Like Stockholm is one of the locations, so they have many, and they could be smaller places. And it's a really big one. So after they recorded it, they divided the database among 3 labs in Sweden, one in Stockholm, in Göteborg, and Uppsala. Doesn't really matter. The labs, really sort of important phonetic labs, very competent, and they divided the database because there was like beyond every lab sort of ability to post-process it, and all of them post-processed it somewhat differently, the data, and that's sort of bad enough that there were some processing artifacts which depended on the lab which processed that data. The bigger problem for us was that they divided the data geographically among themselves. So data from southern Sweden went to one lab, from central Sweden and Finland went to the other, and northern Finland went to the third lab. So now when we wanted to do the region-based analysis of the data, this was a huge problem because we didn't know whether our machine learning system detects a real source of variation which we're interested in, or the source of variation which was imposed on the data by the post-processing steps. That's actually one of the reasons why we only analyzed F0 and intensity, because those things were robust based on those things survived the treatment of our Swedish colleagues, but intact. But these things we have to be kind of aware of that. It might become an issue when you are combining databases. That somebody has collected Assamese data and somebody else has collected Mizo data and somebody else connected, I don't know, Angami data, and they are more or less the same. And when you combine them together, and you want to see the differences, you have to be aware of these issues. Then maybe the data, sort of by definition, almost were use different mics, different post-processing, different chopping techniques. All of these things, they are recoverable sometimes, but one has to be aware of that. Very often you see this sort of. That's why. What I was saying earlier, that when you see these very good results, too good to be true, that's when you start to be suspicious. Whether you are not actually seeing the effects of other source of variation to the one which you are really interested in. This is when one has to get really sort of panicky almost when you see perfect results. So I'm going to just, please, Lina is here so you can stop me when I talk rubbish here. This is the database. The Assamese database, or subset of the Assamese database, which we have been looking at the data. I just use it as a sort of example to illustrate some points. So it is the subset of the database I had on my disposal to run these things. So we had is the recorded Assamese version of the Northern Sun. It's like about 600 people and with 60 towns. This many female and this many males, and this was the information Lina and her colleagues collected: age, gender, place of birth, occupation, father and mother's occupation, and many things like that. Oh, and I forgot to put the most interesting part there, which I find really, really interesting: the degree of pride in you speaking Assamese. That's cool. We have to I'll be adding that to the databases. Actually. All of this information are stored in a meta file, which contain things like the file name, region name, all of those information. I covered the information there, which I thought would be potentially sensitive. I made double sure that I actually took a screenshot of that covert, so it should not be recoverable. You should not be able to remove it. So yeah, this is how the meta file looks like. We are going to hopefully create similar meta files in the afternoon, with pretty much the same columns. Well, maybe fewer, but something like that. And yeah, so this is how you actually create a meta file. And what's important here is that you assign each recording or each, usually, this is kind of a little bit arbitrary, but usually you design some sort of file name agreement. How will you call the files? And very often what we do is that we kind of use something which is like they can identify the speaker or whatever, the database entry uniquely, and maybe we usually put there just for ourselves the sort of the main source of variation which interests us. Like here it's sort of the region, 4 letters for a region, and then 4 letters for the speaker, some ID. You know, in theory, what you can do, you can give completely arbitrary names to the files, if you want, and then you use this meta file to match the files with the things. But we usually don't do that because, you know, like it complicates the sort of, you know, we are usually very curious, so we want to quickly see the results, you know, and you can use the file names to split the database, or somebody wants to have only look at these particular data, so you just, you know, filter them and send them somewhere or something like that, or share them with your student. So we will come up with some naming convention today for our data if we are uploading them. Yeah. And then, of course, you have the file storage when you store the recordings under these files, other file names. This Assamese database, I sort of spent some quality time of looking at distribution of gender among different recording sites. So here the blue, these are 60 recording sites. This is a sort of pie chart for each of them. The sort of telling how much male and female sort of people there are, you know. So these are slightly, they're all the same size, but there are some of those, it's usually around 10 speakers, and sometimes a little bit less, and sometimes a little bit more. So it's 10 on average. It's quite close to 10. There's very few which would have like 14 or something, and very few which would like 7 or something like that, or 6. So it averages very well and is not hugely varied. So this of course means that for this recording site, something starting with A or B probably, is 50-50 precisely, exactly as many males as many females. And you can see that by and large, pretty much for each individual recording site, the gender balance is quite fine. There would be 1 or 2 little outliers, but this is unavoidable. There is always some little irregularity. So this is excellently balanced database in terms of gender distribution of the recordings. Now you might be wondering, why are phoneticians so obsessed with this gender, you know? So, and with the balancing. So the main reason, of course, we were talking about that because of sexual bimorphism of human as a species, there is a very strong source of variation which is gender related, or more precisely biological sex related. So the human biological sex and whatever the hormonal setup influences the primary source of the voice source. The male usually have bigger and longer vocal folds, but also heavier. So it goes, the influence of the sex on the voice goes a little bit beyond the size of difference. So there are clearly some other evolutionary aspects which sort of have formed the female voice to be higher pitch and male voice to be lower pitch. So it's a very strong marker of the thing. So that's why, because we are working with the human voice, and that's one of the first things we can hear, and that's one of the first things the machines latch on. So we have to make sure that we balance the amount of speakers from each of these major categories, as it were. We can, of course, balance it in various ways. We can only allow female speakers, for example. Only allow male speakers. Any balancing is fine. Doesn't have to be 50-50 at all. As long as it's sort of reasonably, that it's controlled, that everything is pretty much the same. Of course, if we only take the female speakers, then we will only know something about the female speaker, about the dialectal variation about the female speakers. If we only take the male speakers, same thing, you know. But the balancing is important. So, for example, like imagine, like this is like obvious kind of thought. Like imagine if for all the recording sites from, you know, the Western Assam, we would only have males, and from the Eastern Assam only females. And then we would get that dendrogram which we produced, and we'd be very happy about that, you know. What would the first reviewer say to us about that? He was like, oh, so in Assam the male and female sound different. That's a good one, you know. So we have to make sure, otherwise that would be called the very extreme case of confounding. That we cannot distinguish the one source of variation from the other source of variation. So we cannot distinguish the source of variation which we're interested in from the source of variation we want to ignore. That was the exact example of the Sweden database. That we could not, the problem was actually not that they divided the data among 3 labs and processed them. The problem was that they divided it precisely on the geographical characteristic we're interested in. It was a confounding effect. So if they randomly distributed data among the 3 labs, that would be fine for us. Because these things would it would be well balanced. The processing side would be well balanced among the different sort of recording sites. So we would get these pie charts if we had these sort of 3 labs. We would get these pie charts, which would be roughly third of the recordings from each site would be processed in a given lab. But of course, we would get, if we did that in the Swedish data, put these 104 pie charts, we would have for the 1/3 of the data, we would get only one color. For the other, we would get the other color, and for the third, we would get the other color. That would be exactly the same thing as having the female data only from one area and the male data from the other area. So that was extremely well unbalanced thing. There was a strong confound. That we couldn't tell whether what we're analyzing is the areal variation or the processing steps of our colleagues. So this is the reason why we are so obsessed with balancing, and why we are seemingly so obsessed with the gender or any other big sources of variation. There is many other ones, you know. For example, age. Again, if we only record older people from one area, this is a more realistic situation, as a matter of fact. Older people from one area and younger people from the other area, then again, we cannot really, and do it systematically, we cannot really distinguish what we are investigating. This is a relatively realistic scenario in dialectal research, because you might be able to only record older people from some very remote locations and young people from a city. Or the other way around, the young people from the city and only old people, young people from remote locations, because they might still speak the given dialect, but in the city you would be only left with the older people, because all young people would speak some other form of the language. So this is much more, and one has to kind of, again, remember that things should be balanced, because otherwise we are falling into this confound problem. We are falling into the problem where we don't know whether we're investigating one source of variation or the other source of variation. Educational level, language education, all of these things would ideally want to be balanced. Now the last thing I want to show you is this sort of representativeness of recordings. This is a very closely related sort of topic to what I was talking about. And this was actually, so this actually is a very big concern in the Common Voice database. There is a question how representative you have this recording somewhere in the database, some waveform, and there is a label or some metadata which tells this is English, and or this is whatever. They use the ISO codes, so this is whatever Hindi or this is Slovak, and that's what you take at the face value. But who recorded? But you don't usually have. You can have some meta information. Maybe, of course, male, female. Maybe some age brackets. That's just about it. You know. Now the question is like, how do you know whether this type of recording is representative of the given label? As a matter of fact, because many of this data was crowdsourced, there is a strong confounding of the sort of, in particular, sort of social demographic aspects of the people who provided the speech, and they sort of, well, yeah, between the language and the social demographics of the people who confound the speech. In many parts, like in a lot of French recordings, actually to native French speakers sound like sort of more, you know, the North African immigrants, recent North African immigrants to France, because they, you know, because they would be they had been the clientele which the campaign or whatever got them, you know. Some people in the database will listen to those data. Some people sound non-native completely, you know, because it was crowdsourced. It was very difficult to control. Some people, like English, for example, we don't know who those people are almost at all. So there was very many sort of. There was some Swedish recording. I was sometimes browsing through them. It was a Swedish recording, which was definitely not Swedish. It was just mislabeled, you know. So that's one of the issues. Of course, the big size of database little bit solves these things because we have all sort of things. But we have to remember that there might be some confounding effects again. That, for example, in France, because maybe if the pay is the same all over the world, then you get some, you know, $1 per half an hour recording. You will get different people contributing in Europe and different people contributing in India, because it's a very little money in one place and maybe okay sort of salary differently. So you get, you know, very different people with access to recording apparatus and all of those. So one has to be aware that all of these type of effects actually exist in the databases we are faced. On the other hand, you know, this opens up a sort of other question. So, okay, so I just said that, you know, there was North African speaking French, there was some non-Swedish people only pretending to speak Swedish, there were people from different areas. But what is a prototypical actually speaker of the language? You know, in current France, first generation, maybe second generation, or even the recent North African immigrant is a very, very good representative of the language as it is actually spoken in France, or at least in some regions of France. So, as you know, as I always say, Indian English is the main variety of English nowadays in the world, by miles with the most native speakers. So why would some standard Oxford English be the prototypical representative of English and not English spoken in Bombay? You know, so this is, of course, this opens the other question, and this opens the question like what we are really analyzing. This is the same with the dialects, same with the languages, same with all sort of things. But this is a more philosophical question than the other. Cool. Yes. Okay. I think this is the last slide. So, I don't know what. Okay, very good. So we have some time for questions, comments, your own experiences. I'm sure that you have actually way more experiences with these type of things than I do. Yes.
Like there is one doubt during my field recordings, and during my first visit, I recorded my audio with the consultant in sampling rate of 44.1 kilohertz, and in different, then I thought like, why not increase a bit? So I chose 48. Now the thing is like, can I use both of these data together? Like, because the sampling rate is different, so will there be any error? Or if possible, can I normalize these two
Yeah.
recordings and then we can minimize those errors?
So sampling rate, of course, is something which can be relatively easily converted. Of course, you can, like in Prat, you could just one click or two clicks, you can convert 48 to 400 or something like that, and that's gonna be kind of fine, You can, so the answer number one is, it depends on what you want to use it for. If you want to use it for extracting F0, extracting some particular characteristics, formants, it doesn't really matter. If you want to, of course, use some sort of script to do that, then you might be better to kind of have them on the same frequency, because some of those you have to otherwise read the frequency if it's automatic things and all that. If you, so you can convert them to 44 or whatever. Usually, you rather want to convert them to the lower one rather than to the higher one, because if you are trying to convert it from the lower frequency to higher frequency, you are making up some information, which is not really there. But if converting it from higher to lower frequency, you are sort of just losing some information. Of course, there might be, as Priyankoo was saying, it depends on what was the range of your microphone. You might not have any frequencies from those high frequencies there at all anyway, if the microphone range only goes to whatever, 20,000 hertz or 18,000 hertz or whatever. So then it almost makes no difference. Now, if you want to, on the other hand, if you want to use the data for some machine processing application, then there is a real problem. Because most of these conversions do leave some mark somewhere. So, because these machine processing things, they are trained to spot differences, and they're not trained to spot linguistic differences or prosodic differences or spectral differences. They are trained to spot any difference. So they really latch on any type of difference. That's where I was talking about this post-processing in these Swedish labs. It would not be a problem if we extracted F0 and looked at the sort of phonetic things, but we gave it to the machine, and the machine went like, and we asked like, from what region it is, and the machine went like, I know what you mean. It's this hum, that hum, and this hum, or this spectral slope, and that spectral slope. So if you want to run it to the machine, then it's a little problem, because you might even decide to convert it all to like 18K or something, to convert them both, when hoping that the imprint is going to be the same. We have this little pedagogical thing in mind, that I told you that when you can record your narrative today in wave format, that would be ideal. But if you have corrected in MP3 or something, that's okay, because we can convert it. But if we do that, we will see very likely that those converted things are put aside a little bit, because the machine, the up-to-vex and all, they will spot that difference. They will spot the imprint of that conversion, most likely. In particular, because it's you are inventing information rather than sort of deleting information. So the answer is, depends. What do you need to use it for?
I'm using it for like finding stress pattern. Was that like that more?
Well, that should be fine. Yeah, that should be fine again. And if you if you do it manually, then it doesn't really matter. Or you listen to that, or you mark something, or you extract F0 and then look at the F0 contours or whatever. It doesn't really matter. That they're gonna be fine. If you use some machine learning technique and you tell it to extract stress patterns, you train it to extract stress pattern, as long as you give it the data with both frequencies, or the data converted and converted, it will learn to ignore that difference, because it doesn't get any reward for that difference. Again, if it's not confounded somehow. So, so that's absolutely fine. Any other questions? I don't actually know how to access the questions from here, so is it possible to see the possible questions from the online audience? There is chat, okay. Maybe I can just tap it. No, this is the one which doesn't tap. Uh-huh. Mm-hmm. So just we learned that it's audible. So that was good. So any other questions from you? Yes?
I have a doubt since you say that the machine learning models, they spot the marks, right? Whenever we're converting them. So just from my case, so when I'm collecting the data, my recorder setting, like default setting is it has to collect at 44.1 kilohertz sampling rate. But when I'm training a black box, right, like GIAN models and all, so I need to downsample the data to 16 kilohertz and also the 16 bit.
Mm-hmm.
So do you think the black box also knows the marks that the conversion will be?
Well, again, the black box, depending on what you are training it, the neural network, it sort of, when you're training it, it has its loss function, so it gets reward from something, from spotting some differences. And as long as it doesn't get the reward for spotting the differences in the transformation, it will ignore it. So, of course, if you convert all of those data to like all of them have 44 1K, and you convert them all to 16K, there is no problem at all. There is zero problem. The problem only arises when we have this confound, when these non-balancing things, So, for example, like when we collect the data today, that for some bizarre reason, all people from North India have recorded their things in WAV format, all people from North India in MP3 format, and all people from South India in the whatever WAV format, but 16K or something like that. So we have this very strong confound. Then we have a problem. If all of these things are distributed sort of evenly, balanced, then it's not a problem. Because when we train any machine learning things, or as a matter of fact, when we fit any statistical model, it's try to capture the variation. And it's ignorant to where this variation comes from. So what we need to make sure that the variation comes really from the question we're interested in, and not some other confounding factor. That the variation doesn't come from encoding, but as long as the variation which comes from, there will be some variation which comes from encoding, as long as it doesn't sort of reward the model, as long as it's sort of equally distributed, so there is no gain for the model to latch on this particular differences, then it's going to be fine. So if its ability to identify dialect cannot be helped by the type of encoding because it's random, then it's okay. Then it will sort of learn to ignore that. Yeah, any other questions? I'm also sort of keen on hearing some of your experiences from. I'm sure that you have kind of had many positive and negative experiences. Usually the negative ones are good because that's when we learn most, So.
One observation from the field. So we go with all the equipments, headphones, microphone and recorders and whatnot. Sometimes the people are very scared to speak in front of the microphone.
Mm-hmm.
Particularly when you have something on your body over your head and the microphone is sticking out.
Mm-hmm.
And they do make a lot of errors at that point of time. And some people do get nervous and shaky voice at the beginning, but then they tend to become normal.
Mhm.
But then you do get a lot of errors.
Yes, absolutely. But it's general, of course. This is magnified in the field recordings, and in particular in the communities which are not recorded very often. But this is, I think, a completely general trend. If you take the undergrad student to a studio, of course they might not sort of be visibly shaken, but they don't speak the same as they would speak normally, and it takes a while. So we always this is one of those issues that we always sort of record this lap speech. We have to be aware that even when we do the field recordings, it's a little bit of a lap speech based on what you are saying. The people are sort of self-aware and and maybe uncomfortable. And the worst thing, of course, happens if they hear their own voice. That's just for all of us. Like we are kind of used to that because we do hear our own voice, but it's strange because, of course, we perceive our own voice very different to how it really sounds. So yeah. So this is for the people who are not used to the recordings. When you know, sometimes with the students even, I don't know how it would be in the field, but when you just check whether it was okay and you sort of play it, they go. Right, yeah.
And also when it comes to dialects, because I'm a speaker from the eastern part of Assam, so I speak Eastern Assamese.
First, we have
We
to
cannot hear the questions
Oh
actually.
yeah, sorry. No, this is broken. It was a successful attempt to get the online community alive. Or maybe here. This is the one which is working. So we can do it this way. We can take this. And I can use that.
Okay. Yeah, so I was saying that whenever we went to the field to collect dialectal data, so I'm a speaker of Eastern Assamese, hopefully. And when we go to Western Assam, so they have a very different dialect. And because I'm speaking to, I do not know any of the Western Assamese, I can't speak any of the Western Assamese dialects. And because I'm speaking to them in Eastern Assamese, they tend to start speaking in Eastern Assamese. No matter how much we tell them that you know we need the Borpetia dialect or the Nalbaria dialect.
Yeah.
So that is one problem that we face. And what we usually do in that case is we take a native person from that particular place and then as the contact person, and that person kind of instructs them or do most of the talking.
Yes, that's cool. Yeah,
Yeah.
absolutely. Of course, with dialectal research also there is, unfortunately, this prestige assigned to some dialects or over the others. This is another of the big issues, that people then sort of refuse to speak the dialects maybe, which are deemed as less prestigious.
Yeah.
And they might to sort of, the dialectal research
That
is
is-
difficult.
That is why, how proud are you of your dialect?
Exactly.
So if they're not very proud, they would start speaking in, try to speak in the standard variety.
Yeah, exactly. But as our analysis shows, your elicitation method worked because we can actually, discriminate those
Yes,
dialects.
yes.
So it was good, absolutely.
Anyone else?
Continuing on that,
Mhm.
I collected some data recently on a Creole that is spoken in Assam. So in the older people, they speak like the intonation pattern as audible to me is different than the younger people. The younger people try to speak more like Assamese, that's the official language of the state, and the older people speak differently. So just by hearing the intonation patterns, it's very different. So it's kind of very interesting.
Absolutely. It's super cool. And of course that can be, then you can have an hypothesis how to sort of represent the intonational patterns, what type of, what happened, how did that intonational pattern come to being, and all those things,
Yeah.
absolutely. We did some of our actually very original research on this. I don't actually have any examples. We used very old-fashioned techniques for that. Was on the exact Sami. North Sami is one of the Sami languages spoken in North Europe. Like that's the only one which is sort of kind of viable. It has about 15,000 speakers, and it's the sort of broadcasting language, both in Finland and in Sweden. Even on the, there are some channels dedicated to that. But it is spoken in at least 3 countries: Norway, Sweden, and Finland. And there is a very clear, even I can sort of hear it. I don't speak Sami, nor really Finnish or Norwegian, but even I can hear the difference, like whether somebody Sami speaker is from Finland or from Norway. And so we did some. There was one of the first applications actually where we used this sort of sound change, essentially, a language change, because those two, it's technically the same language, but they are becoming mutually difficult to understand because of intonational patterns exactly, and some lexical stuff. Numbers, for example, they just take from majority language, but yeah. So these things I guess happen, and they are super interesting to actually look at, because it's what. For me, it is like the holy grail of linguistics, because we are looking at the sound change, language change. We have this sort of evolution, at our fingerprints. All of these sort of creolizations and these, mixed languages, and like Nagamis and all of those things. Those are sort of amazing opportunities, in my opinion, to actually investigate, because that's a sort of evolution happening before our eyes. Of course, this has also those kind of repercussions of some linguists would say, like, only this particular variety of this dialect is the real one. We got, for the Sami speakers, a lot of the kind of the younger people said, like, oh, no, you should record my grandma because I don't speak North Sami well. And I was like, well, but you use it daily to talk to your friends. Yeah, but we can sometimes switch and sometimes use the different things, but that's the living language. The grandma, with all due respect to grandma, that's a sort of language disappearing. The way the young people are using the language as it is. So that's the most fascinating thing, in my opinion, to actually see how the language in vivo, how language in real daily use actually is used, with all of those dialects as well, and all the accents and all the Creole languages and all that. I think that's super fascinating. I find that the most fascinating thing, way more than some, conservation of some particular ways of speaking. I've been living for about 25 years. 25 years ago I moved away from Slovakia, and my Slovak is fine. Nobody can tell, in some sense. I have no accent whatsoever of anything, and it's fluent enough. But I use sort of idioms, like I'm a time warp. I use sort of the 90s idioms, and people sort of like, as I said, there's no accent, but sometimes I say something, people are like, I never heard that for 20 years. So that's sort of I'm not a good representative of the language, and I have sometimes there are new idioms, and I sometimes go like, this is wrong. But then I go like, oh, who am I to say, that this is what people use. Some inflectional patterns has changed ever so slightly and all that, and I just go like, this is horrible. But so we can see the language change, and is my version of Slovak somehow superior to the version of the Slovak which nowadays people speak? Surely, it's silly. Even though some of those idioms which are really hurting my ear are actually calques from English, from advertisement and what have you. So they are kind of wrong in some sense. From a structural linguistic point of view, they are sort of wrong, but they are there to stay, and that's how the language is. So I think if I could anything, I strongly encourage you to really investigate the language on the street, how people really speak daily. And this is a fantastic region for doing exactly that, because people communicate in so many amazing ways. Any other? I don't know what time is it, by the way. I cannot see the clock, and I know it's off
1, 3.
anyway. Sorry?
1, 3.
1 plus 3.
Yeah.
Oh, so we are past our. Okay. Good. So, thank you very much. And then we go and eat, and I guess we meet at 3 o'clock here, and we do some hands-on work. I'm very excited about that, and let's keep fingers crossed that it's going to work. And I would love to welcome also the online participants. Please join in, and we will
hopefully be able to do these all of these processing kind of remotely.
Thanks. Just switch it off. And Tukka, sorry, before we go, did you share with me the folder and? Oh yes. Uh-huh. So welcome. Sorry for some small technical setup. What we want to do today here is to kind of do some hands-on work with our data and hopefully create a database. So welcome to everybody online. Maybe we don't have to be watching my private chats. Yeah. So I few questions. So how many of you in this room and maybe online have used Prat? Almost everybody. Is there anybody here who used Prat? Do you have it on your machine somewhere ready with you? Cool. Does everybody have Prat installed? Did you install it? The ones who don't have it? How many people do not have Prat installed? Everybody has the Prat installed. Cool. Excellent. What about online? Please, for the online people, the way how this room is arranged, the chat and everything is behind me. So I would ask you to just put your mic on if you want to say anything or have anything to contribute, and just say it. I think I will be able to hear it, and then that will sort of grab my attention, because otherwise I cannot monitor both of those things at the same time. So for those who have not used or installed Prat, you can just go to the website called prat.org, like that. It will prat.org. It will redirect you to the Prat website, which is hosted in the Netherlands. Prat has been developed by Paul Bersma and David Wenig, and it's very well maintained by these very eminent and sort of mature phoneticians. It's been updated all the time, and new versions are being released and all. As we who use Prat kind of know, appreciate, and also dread a little bit, because every new version means that there are some changes which we have to adapt to. Anyway, you can download Prat to any of these systems. So I have a Mac, so I would go here, Windows and Linux and all of the other platforms. It works quite well on many platforms I have tried. And so please, if you haven't done that yet, please do that. It's a very simple installation. The only potential problem is that in some particular operating systems, because what you actually do for this is not an installation type of a thing, it's an exe file. So for Windows, you essentially download exe file and run it on your machine. Unless it's changed very recently, I haven't installed Prat on Windows for a few years. On a Mac, there's the DMG file which you just unpack and it sort of works out of the box. And similarly for the other platforms. So that should be quite straightforward. The only potential problem is that your Windows or Mac operating system might be a little bit reluctant to run an exe file downloaded from the internet. So you have to kind of know what to do. They usually have to hold some key or something like that, put your password in and what have you, something like that. So again, these security things keep changing. So I don't really know precisely what is the current trend. So I hope that the people who are online, the most of them, are working on that right now, and will have the Prat sort of. You don't actually install, you downloaded it, and you can take our word if you sort of didn't make a typo and you got to this. This is a very 80s looking website. This is, by the way, how the first websites looked in the 80s. It's safe. It's like many people here are nodding. We know that. Apart from that, you might become obsessive with the signal processing and sometimes might lose your temper when you try to do Prat scripting. It's relatively safe. I mean, it's perfectly safe for your machine. Yeah, so Tuka has sent me the updated version of the presentation. Which I downloaded now, hopefully. We have made some small changes, so this is actually the presentation, and we can a little bit run through some sort of what we are planning to do. Okay, so yeah, we are gonna. Hello. Is it like it's some echo of myself? Maybe somebody has put the microphone on. Yeah, and it's coming through. So we are gonna be designing a corpus, creating a corpus today. So what is the plan? So we will prepare, hopefully, if all goes well, one little database one little corpus which contains sort of two databases. One which is the North Wind and the Sun in your language, in the language which you have hopefully recorded. Has everybody recorded their North Wind and the Sun? How many people did that? Everybody in the room, excellent. I did as well, by the way. And online, I hope many people did as well. Excellent, excellent. There are quite a few people who agree. So, and of course, I also asked you to do that in English. I hope, yeah. So everybody did that in English as well? No, you can, of course. Again, we were talking about that earlier today. You can easily opt out from taking part in this. Absolutely no problem. Perfectly understandable. If you, I don't know, for whatever reason, you don't feel like comfortable sharing the data, or you don't feel comfortable, whatever, reading things in English or reading things in language or reading in general or whatever, it's absolutely fine. I didn't do English version myself. So then we create a metadata table, or we will do this in parallel, hopefully. And then, of course, and we chop the recordings, which you have recorded, to individual utterances. And then we rename them, those chopped messages, and then we upload them somewhere, or get instruction to uploading them. And then hopefully we will have database. I don't know, we should have about 40 participants. There is 5, 6, 7, 8 sentences, depending on the language. So 40 by, let's say, even 5, that's 200, times 2, the 2 languages for everybody. So it's, what was 200? So 400. So 400 sentences. We might get some results out of that. We'll see. It's a very small database. So what are we hoping to actually see in this database? So we are hoping that something similar to what we saw the world languages, that maybe with a bit of luck, and of course we have to remember that the database is very small, with a bit of luck, we will get some hints of some, distribution of the languages, maybe geographically correlating to geography. Of course, we have quite a big proportion. We are lucky to have quite a big proportion of representation from Northeast Indian languages, so we will probably be able to zoom a little bit on them and maybe see some topological relationships between them. If we are lucky. If we are not so lucky, it will not really work, but we will learn. Maybe it's also lucky if it doesn't work, because we might learn many ways in which this type of exercise may sort of not work. So let's just dive in and see what happens. So we will create So the Tuka has prepared some template for the metadata table. Do we have that? Can we share that one? Have you shared it with me? Which way? Can we briefly not share my screen? I'm not particularly sensitive with my screen. So there is this type of a metadata table. Can you share? Did you share it with everybody? Tuka will send you the request to the email address you provided to us to share. And this is how the table looks like. So I don't know, can you all see it? Probably more or less, yes. So Tuka created, these are your, this is like your identifier. Just everybody has the row there. This is a little bit scrambled, your email address. Scrambled so that you should be able to recognize it. We just don't want to share all the email addresses for everybody. So it's like a scrambled email address. This is sort of his and etc. etc. And then what you want the information from you, everybody should put some sort of email address, speaker ID. Can this guy, by the way, hold the... let's not start speculating. I'm gonna add one more row here. And I'm gonna put my email address. And so I would create some, you can create any, essentially, sort of user ID. 3 characters. 3 characters, okay? 3 characters, I'm gonna put it here. Three characters. So I can put something like Jura or something like that, you know. It can be part of your name, it can be ABC, it can be anything. Maybe let's start with the letter, and then can be numbers. If we put only numbers, sometimes we do the processing of a lot of data. What can happen is that the machine will interpret that as a number, and you have to kind of keep converting that in the right way. So let's put some letter somewhere there. Then we put your mother tongue. This is the language this is actually sort of essentially any mother tongue you can choose, because we will have the other system for identifying in what language the given recording is actually performed. Okay, so I would, for example, put like Slovak here. City, this might be the place where you live. These are going to be the metadata which we might use for, figuring things out. Maybe here we might be more, because we might sort of put the associate the language you are speaking with this city when we are plotting it on the map. So maybe here we will want to put maybe not necessarily the city where you live, but where the language where did you learn that? Where did that come from? So I would put Nitra, it's an obscure little place in Slovakia. State. Well, this would be for you, would be the state. We don't have, Slovakia is so small that we don't do states. So I would put Slovakia here. Gender, M. You can put M, F, or O if you want to put some other gender. Let's stick to those 3, maybe. Age. And then you put whether you agree to share your data with the others. And whether you agree to use the data for educational and scientific purposes. Yes or no? No. Okay. I do share, but I'm just going to encourage you, if you feel free to say no, and then we will think again. And of course, when we have all no's, then we will say please or something like that, So I'm going to say yes. So when Tuka shares this database with you, you just fill your row in this way. Try to be sort of consistent a little bit. This is very important when we create metadata. It creates a little bit of headaches. Usually, most of the things are sort of savable by coding, but it just requires extra lines of code. So it's very handy to kind of stick to it and put, let's say, 3 characters for the speaker ID. You know, and of course try to be unique. We will check if by accident occurs that, you know, there are 2 pris or something like that, then we will ask somebody to change it. Mother tongue, now we will actually have the, yeah, you can put sort of essentially any mother tongue or mother tongues here. I will show you a little table. We have the languages you reported in one of the forms you filled. Those we found the ISO codes for them. These are Indian languages. That was actually, I was waiting for Tuka to send me because he updated it kindly. So there is a slide here later on when these ISO codes are listed. Okay, but we will put this ISO code because this is the language of the recording, if you know what I mean. But you can put the mother tongues whatever you wish. You can use ISO code. Then we will sort of somehow try to make sense of that because we have no clue what languages there are. Coming back to here, yeah. So, for example, what's kind of good thing to have is the gender. Don't put the capital, put the lowercase, otherwise somebody has to convert it. Computer is sort of silly, it kind of doesn't know that capital M is the same as lowercase m. It can be told to consider them, but it's an extra line of code. Try not to put some spaces somewhere there, because also those spaces, you know, it's kind of invisible if I put here, like, you know, M and a space and go away, it's invisible, but the script will notice, and then it will create the new gender category, which is M underscore, like that, you know. So this is kind of this is a dull thing to be kind of consistent, but it of course helps when you have coded a lot and you start thinking like a program. You know what program might like and what it might not like. So now I can see that Tuka has shared the thing. So I don't know. Please feel free to fill it in. Oh, it's filling up nicely. Sorry? Oh. Oh, sorry, Abhi. Now. One thing which we could have changed, for example, was the states. We could have come up with, and we might need to post hoc come up with some proper abbreviation of the states, so we know that UP is Uttar Pradesh and things like that. But that can be done for the small database like this. It can be done kind of online. For if you do something really big, you might create some drop boxes or something like that. So it sort of simplifies your. This can be post hoc changed, like we roughly know what corresponds to what, and unified. This is cool. So, okay, I can leave this on briefly, so you can use this if you want. There is a change here. Right. Ideally, yes. We could, of course, as I was talking earlier, we could have collected where you are staying, because that might, of course, influence your language and all sort of other information. But let's not get too ambitious. you know, we will have relatively little data. So, yeah. Okay. Because there is a possibility that somebody is missing here, then of course you just add your email address there. And we needed to kind of pre-fill it somehow, because if you started filling row by row, it would create all the chaos. You know, these things are, they support the multiple people using that, but not that greatly. You know, the lines would start getting rewritten and all that. So this is probably safer. But 1 or 2 people can be easily added. As I said earlier, like you can withdraw any type of information. You don't have to fill all of the ages. Like if you don't feel like sort of telling somebody how old you are or something like that, it's absolutely fine. Cool. So, So I can see that many people are sort of done, and the others, you can do this now or later, and people who are online as well, of course, we will get everything. So next step is to look at the files, to look at the recordings. So now it's time to open your Prat, and so you know, we open the Prat by sort of double clicking on it or something. It usually, well, I can open your Prat, my Prat, sorry. Usually it opens with this Prat picture, which almost every phonetician has a reflex to close immediately, but some people leave it. I'm wondering sometimes how many sort of person hours have been spent in human history in closing the Prat drawing windows, you know. I must say myself, I must spend like weeks of my life to closing that Prat window. So, and then you get sort of, you know, Prat. Then you open the file, you record it, hopefully. This is, if you know where it is. Actually not sure if I remember where I put mine. Read from file, okay, it's here. I put mine right here. Doesn't really matter how it's called at the moment. Okay. So if all goes well, I record in the WAV format. So I have it opened straightforwardly. This is like one recording with my Slovak version. I don't know whether you actually have recorded the files in one long recording, presumably, hopefully, most of you. Does everybody, what type of formats have you used? Have you used WAV format, your file now? Does anybody have any other format? MP4? M4A. We can try to see whether Prat opens it.
I have formatted it to WAV.
Okay, yeah, that's fine. Now, this might be something. Can you put a little note in the metadata, just beyond, just to put whatever converted from, you know? Everybody who converted the file, we might be able, the machine learning might spot it. So we might be kind of, if your data point is sort of outstanding, we might have this extra sort of remark. There is nothing wrong with this. In particular, for sort of educational purposes, it might be very educational. That's why I want to see it there. Everybody who kind of has the file opened in some other, yes. Our voice is not clear. Is it better now? somebody recorded someone else narrating this story. That's absolutely fine. Although we would want to know then the language and the sort of maybe for the metadata. I'm talking to, is it Amanda? For the metadata, we might want then you fill the given sort of log with sort of that person's information. If you know what I mean. You don't have to change the email address. It really doesn't really matter. That's an arbitrary sequence of strings. But maybe you can fill that person's information. So, for example, if it's if it's a different gender than you, so we are not sort of considering somebody, some file which is recorded by female as recorded by male, or the other way, vice versa. So that would be super cool. The voice is still not clear. There is a buzzing sound. This is not for me, unfortunately. Hello, hello. There are some complaints from online version that the voice is not clear. Hello, hello. Is it better? Clear for me, okay. Maybe, of course, this might be in theory on a receiving side. Who knows? I'm gonna rearrange it. It might have been sort of upside down, okay. Hopefully it's better. Yes, many people say that it's okay, so maybe one can maybe log in and log out or something like that, or check the other things on the other side. So have people in general managed to load their file into Prat? Okay, so now this should be relatively easy. So now we open the file. When you press, of course there's many people who use the Prat, but you press this, you select the file and press this view and edit. It then, with a bit of luck, it opens. And there is a waveform open. Presumably your version is longer than 10 seconds, unless you are a really fast reader. So then if it opens, you will see nothing here, because some sort of spectral processing and what have you is a bit slow. So the Prat is set that it only shows the processing for things shorter than 10 seconds. So then you can select like this. I'm just selecting I press down the whatever mouse here and select the portion of the speech, press the cell here. And here you will see that you have some particular spectrum and all sorts of quiggles and quaggles. So there are some formants, we can hide them. Then there is some not very good signal process, the pitch processing. There is an octave jump here, for example, easily visible. We can look into that in a minute. Let's first chop the files. We can chop the files, so I'm gonna play, I'm not sure how it is gonna play, but I'm gonna play this sound. Aha.
Severák a slnko sa raz hádali, kto je silnejší. Severák a slnko. Severák a slnko sa raz hádali, kto je silnejší.
Now, in this particular case, I don't think that we are sharing the sound from my computer out. I don't know if you can hear it. It doesn't really matter. It doesn't say anything which is particularly informative. And and it's in Slovak anyway. So what you do, if you listen to it, you listen to it by press. You can even select a little bit like this. And if you press down the interval here,
Severák a slnko.
It will play that given portion. Okay, I don't know people around whether you can.
Severák a slnko.
So I have chosen, this is the first phrase, actually the title. Severák a slnko, north wind and the sun. In Slovak, rather bizarrely, we have a word for the north wind called severák. It means like norther or something like that. It shows how important the north winds are in my part of the world. We don't have the word for south wind. We would have to say south wind, but for the north wind we have. So now, I select it. It turns red. I selected this utterance here, severák a slnko. So it's 1.22 seconds. You can again just double check whether it's the correct bit.
Severák a slnko.
And then the easiest thing, I can go here to the file and press save selected sound as wave. Press that. And then I'm gonna save it here. So how shall I save it? I'm gonna double check my, did I lose my, I closed the metadata. I'm suffering from the syndrome of a manic closer of the things. I always close all the windows and then I regret it. So I'm gonna here double check the speaker ID. Your I put. So I'm saving this your underscore. Then the sorry. This is the Is this the correct one? No. Are you sure? I think you had one more language. This is not the correct one. I have two versions of it open. Here. This is the correct one. So I take the language first. Sorry. So I save it as language. Svk underscore my name, or rather the three-letter speaker ID you used here. That's very important. Three-letter speaker ID precisely as it's here. The language, the language as it's here. I had the silica there, by the way. Your gender. The same when I put there, and sentence 1, S1. Okay? S1. I'll share it from here. So it's the LAN. That's the three-letter abbreviation of the language S in the metadata. Then underscore person. That's the three-letter abbreviation used in the metadata. Try to be consistent with the capitals and lower cases. Then underscore, then the gender FMO, and then underscore S1, first one. Yeah. These are the ISO codes. Yeah. Sorry, chopping them into sentences. Yeah. So this is the sentence. This is the first sentence. I selected it. And I'm saving it. Now, actually, what I'm gonna do, I'm gonna put this, copy this, and put this to my whatever it is, the clipboard, and save. Now go back to Prat, and this, as it happens, is the second sentence. Okay, I selected it. You can select the sentence a little bit further apart, a little bit less. If you go out, you should mostly be able to see the sentences. In particular, if it's a read speech, we leave some gaps, we take a breath. So you can more or less see the sentences. You can a little bit play them. So this is the second sentence. I'm happy with that. Save selected sound as WAV file. I copy, I pressed Control. So I copy this, but put S2. This is the second sentence. So we will have, for some reason, the Slovak version of the North Wind and the Sun is chopped to short sentences. So I will like 10 of them. S2, save. Now, because I've done this before, this is the third sentence. I happen to know, I can listen to it. Cool. Save selected sounds away file. You only put the clipped ones, yeah? Yeah. We want you to clip them to sentences, and then we put those sentences or utterances into the folder, and those we will process. Okay? So I'm gonna now, so I could continue, but this is more important. So I can share these ISO codes, and these are the naming conventions, yeah? The three-letter abbreviation of the language from this table. If there is a language which is not here in this table, try to put ISO code Slovak or something like that, the Google will tell you the ISO code and or ask us. The one thing, why we want actually, by the way, ISO, because with the ISO we can find some coordinates automatically for roughly where the language is speaking. We can associate it with all of those map features and all those type of things. Well, and we will, through the ISO, we can sort of try to potentially access some databases which contain some information about the language, essentially. So, yeah. So let's all go and chop and ask any questions. Let me see here if anything is happening on this front. Can I see the chat, please? Nothing seems to be new in the chat, so all is good. Any questions? Of course, if you have any problem, please raise your hand. There is plenty of people with a lot of experience here with this type of work. Tuka and Abi and myself and Lena and like more than half of you are experienced with that. So please ask for help if you need. So raise your hand. Raise your hand and yeah. And of course, when you are done, you can upload those files to the folder which Tuka provided. Tuka can keep a eagle eye on that to see whether there are any potential issues.
So once we chop the sentence, so we need to copy it.
Yeah, you can copy. We can copy to the server. Yeah, exactly. So have you shared the drive with me as well? Yeah. Oh, this is okay. Yeah. This one, yeah. And audio, okay. So there is the audio, and I can just drop those few sentences I made, just drop there. Like here we have the puja, then there is a sort of, this is hin, pu, okay. And of course we have the English version as well. Like let's do one language first and then the other language, okay? So in the other language, we just put eng at the beginning. This is the language of the recording, okay? If you have it recorded in English, we put eng and then your name, abbreviation, like the rest is gonna be the same, okay? So, and we will figure out, because we are interested in maybe checking whether we can somehow cluster the recordings based on the sort of mother tongue of even in English. I have to admit I don't have high hopes that it's going to work, but it's worth a try. So, but we of course find the mother tongue from the metadata. It's fine. If it's a long sentence, absolutely fine. Yeah, it doesn't really matter. for this particular purpose. Let's chop it by sentences. So we actually shorten the sentences. We chop them already. We sort of split some longer sentences to shorter. So it's not sort of a canonical version, but version which is good for this type of a thing. So that's another possibility that you might decide when you record something to kind of a little bit adjust the text for your purposes. How is it going? Any issues? Tomorrow, if all goes well, we will use these data also to kind of look at some very simple classifiers, just an example. Maybe we will extract maybe some very, very rudimentary measures like F0, maybe average, or F0 standard deviation or something like that. But then Priyankoo will show you some scripts, how to kind of do that in an easy way and a fast way. So we will use hopefully this database for several different purposes. There is some information in chat. Can I see the chat here? Can I see chat here? This doesn't. Yeah. Okay. Oh, there is a machine. There is a control machine. Okay, I can do that if I knew. Oops. First sentence about 8 seconds long. It's fine. It's fine. Okay. I will go through the process of chopping in a second. And yes, let's do the same process for the English recordings, but there we put the ENG as the language name. So all of those English recordings will start ENG underscore 3 letters for you underscore gender underscore sentence number. Yeah, long sentence is fine.
As long as it's below 20 seconds.
Yeah, exactly. As Tuka is saying, below 20 seconds is good. So again, the chopping process. I'm very happy to do that. So, oops, no, this is the wrong program. And then you can press view and edit the recording, and here are the sentences. Sometimes it might be a little bit misleading. I'm selecting it by kind of pressing the whatever on the mouse. Let me see how does it work. Is this a real mouse? Yeah, like that. So I press the what is it, left button, and hold it, like I drag it through. So I select something. You can press this selection. It sort of zooms in on the selected thing. So which one was? There was the first, second, third. So I already used these. Fourth one looks like this. So you select, this looks like a sentence. You select it, you listen to it.
Severák a Slnko sa rozhodli, že zvíťazí ten, kto donúti cestovateľa vyzlieť si plášť.
That's a sentence. So you select that sentence roughly, more or less. You can do it sort of, maybe, you can see where the speech signal starts and ends roughly. This was not particularly good recording. There is a lot of noise. Well, don't worry about that now. And you select the sentence, and you go, say, press File, Save Selected Sounds as a WAV file. It opens the whatever, some folder which you decide to use, and you take language, your 3-letter abbreviation, male, and this is S4. Now you save, it should be sitting there. Next you go further. Maybe this is a very short sentence. Indeed it is. So I can press File, Save Selected Sound. I actually kind of cheat by pressing this S4 and then changing the 4 to 5 and save. Next one looks like this is a sentence. Indeed it is. If the sentence doesn't fit into the window, you can press this out and go out, out, out. Or if you want to zoom in, you can use this in, and zoom in on the signal. This Northwind gave up. Say it again. Absolutely, absolutely, yes. If you find some nice place, somewhere quiet, or we can be very quiet, but maybe outside would be nicer. Perfect. Maybe I should go as well to record the English one, because I haven't done that. Sentence 7. Save. Eight. And 9. So this.
What to do if it's more than 10 seconds?
10 seconds is okay. More than 10, how much more than 10 seconds?
10.45.
That's fine, that's fine. Up to sort of 20, it's okay. Of course, if there is some natural place where when to chop the sentence in halfway, that also can be done. But if you sort of took the deep breath or something like that, it also can be done, it's not a problem. What we will do with these sentences, we will sort of a little bit scramble them together anyway. So we will try to calculate the sort of mean representation for each of you, or of the language, even if we have multiple speakers of the language, and see what happens. Oh, now it started nicely. By the way, in our chat we have provided quite a few sort of translations of the versions of the fable, and we asked those which we didn't have the language to sort of translate it yourselves. How many people did that? Yeah. Did you? If there was, so for example, there are a couple of Angami speakers here. I don't know actually. Yeah, there I can see them. Did you sort of share that translation, or did you? Were you actually from the same village, if I understand, if I remember well? So you shared the translation. So it's the same text you recorded, both of you, or? Excellent. That's fine. That's absolutely fine. I'm just curious to see what sort of differences we have. Of course, if you can record also the version with what Janae recorded, it would be kind of cool. Then we could, of course, we have to come up with some new abbreviation, you know, sort of RNS and RNJ or something like that. So, you know, that might be kind of cool to have. Ideally, what one would want in this corpora would be to have the, you know, same speakers talk in all the languages, you know, in some sense. So we can balance things. So you can again know that what you are looking are not speakers' idiosyncrasies, but the language things. But of course, this is not achievable, really. But when there are opportunities like that, that's kind of cool. Sorry.
Sorry, this sentence is very long in my mother tongue.
Uh-huh.
This first sentence is very long in my matter.
Aha.
If I
Mhm.
translate it.
The north wind and the sun were disputing which one was strong.
Yeah.
Then you can translate which one was stronger. Then a traveler came along, wrapped in a warm cloak.
Yeah.
We can change that. It doesn't have to be sentence by sentence translation.
Uh-huh.
It's actually in most languages. If you, I was just looking at it. If you look, I guess here, where is the audio? You know, different languages have, like my Slovak translation had 9 sentences,
Yeah,
but I had seen some things with like already 11 or something. So it doesn't really matter. You can chop it to.
It is 13 seconds long. So.
Oh, that's. Oh, you have it translate. You have it already recorded. 13 is fine. As Tuka was saying, up to 20, we are good.
I heard it then.
No, up to 20 we are fine. So it's all good. And of course, otherwise we could just split it somehow at the recording, but 13 is fine.
Actually, there is a long pause because there is a 1 comma.
Mhm,
So
mhm,
I
mhm.
chopped it here also.
That's also okay, yeah.
I have realized that I can't read my native language anymore. The script I can't read it.
Synthesize, no.
There is no possibility. I have done English one, but I haven't been able to do Gujarati. I was trying to read the thing. It's just not possible.
What can we do, you know? We can send you back to school.
I can't read Gujarati. I can't read Hindi. I know it's very well.
Yeah, that's okay. That's
So
fine.
that's just one line.
Absolutely, absolutely. Don't worry.
But I can speak multiple languages. This can't read.
There are some sort of, I'm looking at the recordings. I hope you don't mind me running through these recordings. And they are, when you upload the things to the to the audio folder in the corpus, you can kind of maybe go back and have a look a little bit whether your format matches the other things. I actually have it ordered here by name. That's the easy way for me to kind of find my own recordings and check that all seems to be fine, you know. Some of them, for example, some of the recordings, I don't exactly know why is that, but they sort of miss the extension. So I'm not completely sure whether... You can, of course, if there is anything wrong, you can go here and rename. So maybe I wonder whether this should be renamed to add the wave. And I assume, actually probably the system knows it's a waveform or not, but some of the file names do have the wave extension and some don't. So I'm not completely sure whether... Tuka is waving his hand saying like, I can fix that easily, but it's a good thing to kind of do it sort of consistently. This is when kind of usually a lot of pain later on when using this is a very small thing and we can easily do it by hand, but when Lina probably can tell the very, very many tragic stories where, and all of us who collected some database know that once things get sort of a little bit inconsistent, it can lead to sort of kind of difficult things. But this is super cool. Kiriprano says that her Angami translation might not be the same as the other translation. Should you change language code or NGM is NJM, is that the standard code for the Angami? Or NJM, yes. Keep NJM, and we will, it's an Angami translation. It doesn't necessarily hugely matter whether the text is the same. You remember what we were talking about today, that we had all of these languages from completely different recordings and things still worked. So yes, absolutely. Well, I was talking to the other two Angami speakers here, that if we are curious, we can sort of cross-record all the standard Angami and the dialect and all that. That would be, you know, interesting also to have a look. We can come up with some impromptu little corner of the potential thing to see whether all of them cluster together. For example, what are the relationships? It would be the second mini project on Angami with Genet, which we have done in the last couple of years. Cool. Oops. Say it again. Write it anywhere in the metadata, like, you know, like this. This is fine. We will find it. This is more like, you know, if something is a little bit like outlier, we can go to the metadata and check like what could have caused this, you know, and then we check it out. Sometimes, or usually in metadata, you would have this column which selects a note. And then you start putting the notes, and very often you realize that, oh, there is some systematicity in these notes. So maybe we create a new column for that and capture it. You know, if there is half of them are converted, then we would probably create a column, say converted yes or no, and use that as a source of variation. So that would be another additional source of variation, which we either want to investigate or want to sort of somehow balance out, or signal process out, or statistical process out, or whatever. To ignore, as I called it today, or to make our methods ignore. By the way, that S and the thing, it doesn't, I don't want that number there. I want the S and then that hash should be replaced with a number, you know, like 1, 2, 3, 4, 5. I should have, I think I didn't say that. So, by the way, I don't think that we will do anything else than this today here. I think that on this tutorial, I don't think we'll do anything else than this. So if you are, of course, we might still find some issues, but if you are kind of done, I think it's fine to go. Is no problem. If you have uploaded all the versions and everything, and you're happy, you checked whether your names and uploads look the same as everybody else and all that, feel free to, sorry to cut it a bit short. I never done this type of, you know, all India database creation online, so I had really no idea how long it might take. But obviously you are much more skilled than, you know, then not that I expected, but then I estimated, you know, estimate how long it would take me to do this. So we are good. Of course, if you did not, if you did not do some of the versions, and you still feel like you might want to, you know, you can always, this same process, it's online. You can always do that. Upload more later, if you want. You better run. Particularly if you want to go to the other side of the river.
I want to see the Brahmaputra during the day.
Exactly.
I'm the tour guide for them.
Yes.
This is not part of the one that we are doing, but I just wanted to clarify something. So I'm just trying for a vowel extraction. So when this is for the P, so we were taught that the vowels appear in this tab.
Yeah, this is the live Pratt? No, or just a picture. Is this Pratt? No.
Yeah, this
Oh,
is
it is. Yeah. No, but it's just a picture. No, this is not the real. Like, oh, it is Pratt. Yeah. So of course you want to extract formants.
Yeah.
So you want to show the formants. So these are the formants. So these things you probably know give you the sort of vowel quality.
Okay.
You know. So you can even put the formant listing here. And you have in different times the values in hertz of formant 1, formant 2, formant 3, formant 4. And this is something like E or A or something, E or something like that, no?
Yeah.
Mm-hmm.
A.
A, yeah, okay. It's probably quite E-E-A.
Just sound
Yeah, don't worry. Yeah, it's almost, when it's on its own, it almost sounds like E. Based on the formants, you can see that the first formant is quite low. For A, the first formant could be quite high if it was A like that. There is very many types of A, you know. There's anything from E to A or something like that. So this would be more kind of E like A. But it's, yes.
Okay, so for the written, do we follow the pitch line or the waves?
For,
The starting.
if you want to annotate the thing, right, yes. So you want to extract the vowel.
Yeah.
Okay, so this is a tricky one. So it depends on whether you want to calculate the duration,
Yeah, duration.
for example, and this is standalone A.
Yeah.
So if it's a standalone A, this is just somebody said A.
Yeah.
So in that case, it's sort of, yeah, you can choose essentially. You can choose, you can almost pick this, as you said, the F0 line, whenever there is enough voicing so that Pratt sort of finds it, or you find where the energy is sort of, you know, when the waves sort of start. Maybe this burst, because this sounds something like it's a burst from the glottal stop, so it's like eh. So, you know, you close your glottis, you build up the subglottal pressure, eh, and release. Because you can do the eh, maybe in some repetition, somebody just says eh. You know, that would be a different rendition. It would look very different. So this is a bit tricky, because you might see if you want to do, the most important is consistency. So there is no kind of like true answer. That if I want to annotate the some standalone A or A in some string or something, this is the way you go. You always look at the formants, or you always look at the F0 or something like that. You have to figure out which of these possibilities covers all the cases you have. If all of these, for example, starts with this glottal stop, all are like, you have like eh and ah and oh or something like that, then you can comfortably start here and wait until some sort of, you know, pitch thing fades, or wait when the thing sort of stops doing that. If you have different renditions, then you might need to start, for example, here. So there is no true answer. The only thing which is a true answer is that you have to have it consistent. Yeah. Very often it's actually, when you do this type of annotation, it's a painstakingly sort of repetitive process, because you come up with some hypothesis. Okay, I'm gonna do I'm gonna start whenever the first pulse is. Let's here you can see, you know, and go all the way up to, let's say here, you know, when this sort of starts fading, and you go, and then you realize that, oh, but half of my things actually do not have these landmarks. So you have to come up with new landmarks and then go backwards and say, okay, sorry, I have to kind of, so yeah, essentially you have to find landmarks and stick to them. Fingers crossed.
Thank you so much.
No worries. Do you have any other examples of this A?
Actually, the same story, I sent it to my niece.
Oh, excellent. Oh, excellent.
So to compare between a male voice
Yes.
and a female voice.
Brilliant.
And then she sent the recording and then
Brilliant.
find the pitch differences.
Yes, brilliant, brilliant, brilliant. Excellent.
So this was the one.
Mm-hmm. Mm-hmm.
This was what I found. Like this is the recording that she sent me.
Mm-hmm. That's excellent. You can upload that one as well. You want to? Yeah, you can. If you feel like, you can create the new. If you have all the full recording
Yeah, I have
of
to
the full story,
Yeah,
chop
did
that. If she's happy with that, create some fake ID
good idea.
number and could add her as well. If she's happy to share it.
What about the email ID? That
Sorry.
because we have to enter as per the email ID. Where is that? So we need to add one more here.
Yeah, we can add one more line there. We can do it here or anyway. We will. Yeah, if you want.
Existing.
We come up with anything. This is just something to be able to for you to know which line to fill. You can fill anything there. You know, ABC. You can put her sort of real name or made up name. You know, whatever. We are not gonna. We don't really need to contact the people, if you know what I mean. So we don't really need to know who those people are, as long as they would be cool. I assume that if she's your niece, that she's quite young.
Yeah, she's younger. Like she's 21.
21. Okay. So she's not. I thought she was like 12 or something, you know. But that's cool. That would be super cool. Yes. If she's happy with that. Okay. Maybe. Sorry, I'm just gonna say that for the people who are online, I'm gonna switch my microphone off if it's okay. If you have any questions, put them in the or shout or put them in the chat. I'm gonna stay here. But yeah, we are slowly, whoever is finished is sort of finished. Same for you. Thank you very much for all the data, for participation. Please upload the files and fill the meta file thing, and then I guess you are free to go. Hopefully nobody will be forced to stay longer than the sort of prescribed 5 o'clock. I'm certainly gonna stay here until then, so if you have any questions, please feel free to ask.
So you can end the session.
I would not worry about that. So we go from the beginning of the sentence to the end of, I don't know what it's here. I wouldn't try to chop it. If we start processing the files, in particular for the machine learning, we will leave all sort of traces. For example, discontinuities. And then the machine might decide that, oh, this particular language is characterized by these stray discontinuities. So let's not do that. Of course, that's a perfectly plausible idea. Sometimes you might want to clean the files, remove the repetitions, in some sense, hesitations and things like that, very long pauses. But let's not do that. Let's look really at the as raw data as we can. And then, of course, if it doesn't work, because we are not performance, we don't have to. We are curiosity driven in that particular case. We want to see what happens. I thank you. Please do. Absolutely. And again, in the metadata, you can put the note that maybe, L2, but okay, the naming then is going to be, oh, sorry. Did I kick something? Oh no, it's my machine went to sleep. You can add another. No, here is actually fine, because we will sort of access all of these things based on your one identifier. So you just sort of create, when you're uploading the file, you will have two versions, maybe English, maybe Hindi, and maybe a third one.
super cool.
So then, regarding the research, so I'm working on the unnatural language, which is kind of so in that language there are secondary vowels. So, but the thing is like I'm kind of confused whether the secondary vowel is spreaded or unspreaded. So you said that the F3 is for the roundness. So like the more, the higher the L, like it's a very.
Is it positively correlated
Is it
with the roundness?
proportional?
Yeah, proportion. I don't actually remember how it works. It's the F3 is not, the F1 and F2 are sort of quite straightforward. It's not perfect, never perfect. You cannot really reconstruct the vocal tract shape from the former, unfortunately. With F3 it's even messier. It's a little bit more. Well, it's a little bit depends when you. I would say that it's a little bit interactive with things when you're around it, or 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 something like that. Or whatever you're around, there might be slightly different meaning and direction. I'm not completely sure. Because it sort of creates different resonances, and so all of our constriction in the vocal tract is like with the tube create all sort of resonances, and then you just essentially order them. F1, F2, as the resonances go, you order them, and sometimes it might happen that the resonance, so it's not ordered by any kind of articulation, it's just ordered by which ones, by numbers. Okay. You know? So sometimes there is a resonance, which is not the third resonance, the grounding resonance might be fourth or fifth. Some other resonance in C. So then it starts getting a little bit messy. So what are the secondary vowels? I don't know about.
The sound is like ooh, but the lips are like ooh,
yeah,
something like that. So like same as the
yeah.
So because I was confused, so I did a vowel plot of using that for lesson. In the vowel plot, it shows according to the cardinal vowel, like it shows the unspreaded one. So how to
So they are on the same. They are on the top of each other.
Yes, sir. Yes. Sir.
Well, you just do the. You can easily add the third formula and see what happens. Of course, you will have the three-dimensional plot, but you can just plot F1 against F2, F1 against F3, and F2 against F3. You know, you can plot it like 3 times and see how they will go. It's already super interesting observation that this rounding or lack thereof does sort of doesn't influence the first 2 formats. That's not always the case. There's an Estonian that is unrounded O, and the O, and but that's even and it has sort of more or less its own space even in F1 and 2. So it's not precisely O, there is some tension. It's super cool if it's really rounded. But you can look at the third, you can look at the fourth form, nothing's stopping you. Apart from the, of course, perhaps we'll give you 7 if you want. But of course they stop being reliable. Because it's sort of, the further you go, there's some strange, inaccuracies poor, some strange resonances start slotting in, so the discontinuities. Because, you know, if you have one resonance going like this, changing because of the shape track, and the other resonance going and they cross. All of a sudden, this one, which was formerly F4, becomes F3, and this one was formerly F3 becomes F4. It can happen as well with some shapes, because the resonances stay, the resonance frequency sort of moving, but sometimes they cross, they change order, and this is a case. Then we don't know. Also, formal tracking is quite difficult. It's an algorithm process like F0. It's not
I'm looking into is the tones because like previous authors, one of the authors, he mentioned the tone is there, then there is like clash between another author and the latest present. Also, I need to look into that as well. So far I am not able to find it, but I found one like tonal difference in diphthongs. But that is only like 100 words.
Yeah.
So it's very rare. I don't know if I will try to
things will change, of course, and with these, depending on what we get the communities and how much of it, they can be spread quite easily because the distances are massive. So it might be short as point and up, but having Helsinki, so good luck.
Yes. So like also my language, the speakers are like declining now. So like it's hard to find like proper speakers because they are like getting a lot of old mixing language, like other due to the influence of other major languages.
What would that be
Like Hindi, Nepali, they are
English maybe a little bit sometimes,
yes,
but
yes. They are getting into the language. Yeah, so, but still like I would put this English
yeah, don't worry.
yes. Thank you.
Don't worry. Yeah, maybe. I think we have our own sort of implementation with the in Python now, but absolutely. So we use some of these. I'm not sure what is called. Some of these softwares to render more complex graphs. Like there are these neighbor nets, for example, and there are some other different type of sort of dendrograms and points, and we use some probably or some but it's super. It's if you find them easy. Because there's sometimes these are super easy to operate. Yeah, exactly. Yes. Perfect. Of course, one sort of yes. That's cool. Of course, one of the sort of one has to practice it a little because I'm sure that there are millions of settings because when you have the software like that, it covers there are different ways of measuring distances, median distance or cosine distance or manifold distance or whatever they are. Dozens of different distances. Sometimes these softwares in a good way have all of them implemented. So you might want to see the control, to know what you are doing. So, but it's super cool. I'm sure that there are many others with free software. I might sort of take copies and I don't remember actually precisely UPGMA. So when I don't really know, to be honest, the answer here, but the sort of in general what the difference is about is the so what you do in this hierarchical agglomeration clustering is that you take you first start with all of the sort of leaves somewhere as the nodes. So when you look which of those are the closest. So it means that you need leaves are these vectors which are representing whatever all your conditions. Then you look at which one of these are the closest. So that of course you need some distance measure, so you can define the closeness based on Euclidean distance or cosine distance or any kind of distance. So and then after you find these coordinates, you sort of create this first smallest sort of link, small branch of containing two leaves, and then you have to assign the vector the place for this branch as opposed to for these two leaves. And then you have many ways how to decide what you choose. So you can, for example, usually you can take the average of vectors, and that's going to be your representation, the place for that branch. But even average you can calculate in many ways. You can calculate the average, you can calculate the average, you can do all sorts of things. Or you can then decide, but the next step is like you take this as a class, as a new leaf, this little branch. And then you do repeat the process. So what is the two nearest? And for example, later on you find that this little bit is the, but you have to kind of find the distance from this little leaf to the others. And you can take the distance from the mean, you can take the distance from the nearest of those, distance from the furthest. All of these have some particular applications. So I think that these type of things are all these possible choices. So that's exactly one. Surely ChatGPT or internet knows all of these things, just ask, you know. But I'm just saying, there is so many options. You have to be really specialist in this particular subfield to know all the possibilities. Really? Let's see if tomorrow, I think, Priyankoo will go more into exactly these type of distancing classifiers and all of these type of things. Are we done? Or I don't know what's happening. Sorry. My computer goes to sleep.
Sorry to bother again. I just came up with a question. So I'm doing a field recording because the place where I'm situated, like it is near the river, so the sound figure comes in. So to avoid that noise, I put high pass filter in the recorder. So
yeah, well again, it depends on what phonetic analysis. If you want to do sort of manual analysis more or less, that's fine. It might interfere depending on where you put the boundary. It might potentially interfere with some F0. If you put the, I don't know what is the frequency of the river, it might be, if you put 100 Hertz, for example, as the high pass filter, you put the 100 as the, so you might interfere with all the one of the frequencies below 100. It's as simple as that. So it's but that's life, and it's absolutely fine. You know, and again, the river for these type of machine learning things, on the other hand, of course this is a tricky one. When you want to compare somehow the recordings from multiple regions, when one has a river, another one has a waterfall, you know, what you might end up comparing is the river with the waterfall as opposed to, that's of course a difficult one. And but this is again sort of a bread and butter of phonetics. We have to live with this. So this is a tough one, but we should be aware of these limitations. But sometimes unfortunately the recordings are maybe not suitable for every type of analysis. And yeah. But yes, what can one do? You cannot stop the river.
yes, that is true. So only thing I can do is like just take the speakers to somewhere quiet.
A little bit quiet,
That is not something I can do.
Exactly.
So then there is another thing. I am using two microphones for my recorder because it has two channels. So I can record two recordings at the same time. For that, like I am using one as a condenser microphone and another is dynamic. So like condenser uses this phantom voltage. So this phantom voltage also then like in this record.
I'm not actually sure. I'm not a specialist in field recordings, so I don't really. We have other people in our lab, and Priyankoo, for example, or Lena, or maybe Renee, people who have experience with the field recordings. They ask them.
Okay, sir.
What we usually normally use are these close range mics.
Yes, it's the same.
So those are the close range mics. So they should actually be quite good even removing the thing. But having multiple mics is excellent. That's always good. Because you never know which one touches what, and you can always pick one out. Normally we don't need stereo unless you are sort of interested in some movement or dancing. So having multiple mics is very good.
I record two speakers at one time. So like I give one word as a prompt. So one produces it, then after some time the another one repeats it. So we provide being conforming and
Hard to say.
because like the later one might get influence from the
Might, absolutely. Yes, exactly. That's very possible. In particular, it might of course all depends then on how comfortable they are feeling with the language. You know, if one is more comfortable, then might copy the other one, or the other way around.
Yeah.
You know, if the first is less comfortable, might feel, you know, intimidated by the whatever. You know, so it's difficult. These are human subjects. All possibilities are there. Are very natural, of course, but again, we want to be maybe doing the balancing. So if you have an opportunity, maybe you can swap them after a while. You know, that one is first and then the other one repeats, you know. Again, we are always striving for balance. Everything which gives some particular order will counterbalance. With something.
Thank you, sir. Thank you, sir.
No worries. Yes. It's only 10 minutes or so. It's only like 10 minutes or so. How is it going with the files? Are they being added still? But there's plenty.
Oh, it's the wrong way. No, I mean like from the bottom.
But doesn't turn it around. No. Wow. See, because the bottom is not that easy. That's me. When it's
4 minutes ago was the last one. Oh, that's
But things are it, of course, we are not
no,
doing
but these are modified because I saw this example in this.
People cannot change the things and whatnot.
Okay.
So, hello, people online in particular. How is the processing going? Is everything sort of done? So anyway, I think we will close the session now, and of course, if you have any type of issue, we close the Teams and the session today, the tutorial. If you have any, of course, issues or questions, you can feel free to just send us the text on WhatsApp, and we will try to respond as quickly as we can. So yes, thank you for today, and see you tomorrow.